Hello, hello, how are yous? Oh, let's move this over a bit. Hello, welcome along. Oh, my WinUAE is gone to sleep. Excellent. Here we go. Here he is. Hey guys, how are yous? Welcome along. Yeah, I always have to ask this, but yeah, how's that music? Is it too loud, too quiet? Just let me know, either way, anyway. Or if you need me to adjust it at some other point, because, yeah, I don't have a clue. Sounds fine to me, but yeah, I'm useless at this stuff. Right. So, right, first thing I wanted to do was go back a little bit on a couple of the things that we covered the other day. So what we'll do is, let's go, I should have had this open. Where am I going? Shared. Let me see, tutorials, was it that one, if then else, yeah, let's go with that. Cool, perfect, cheers. I've also changed resolutions and stuff like that a little bit, so I hope that text is clear to read. Not sure if it is or not. Oh yeah. Yes, mine is making no such threats because he's wide awake in next door. So. Oh well. But it's a weekend stream, so I'm going to correct a mistake I made the last time and have a beer. Cool. Good stuff. Yeah, back in Amiga Blitz. What I've done is I've just basically got lowered some resolutions here and there, and hopefully, and lowered color counts and things like that, and hopefully mine's yeah, hopefully Amiga Blitz holds together now for this, because yeah, weird. Hey Nivrig, welcome along. Cheers. Yeah, it's funny when you know, the kids go from, like, you know, oh, they're up at 9 or at 8:30, then up till like whatever, out with friends and stuff. Yeah, no instant gun here. This is your L-Bog standard Peronis, but I had Athar from the Scottish Amiga group over there yesterday, and he always brings a few beers over. So, you know, what was I doing? I was soldering an A500 memory pack for him. Seems to, you know, keeps me in beer. This is all good. Right, Ian, how are you? Welcome along. Welcome along, everyone. Oh, yeah, loads of people here, all the groovy gang. Yeah, thanks for coming along. So, yeah, just, I did go through the, I'm great, thank you. I was just saying it's a weekend stream, so I'm having a beer, and, yeah, you know, correcting the mistakes of the last one where I wasn't drinking, but, oh, I see. So it's 8 and not quite clubbing yet. Oh, that'll be fun times when that happens. Okay, so this is yeah, I touched on if then stuff there the last time, and what we had was we said if something is true, then do something. I kind of touched on it, but and sort of but there are a couple of forms that it can take. So you've got if yeah, if. You do something like this. So you can have it all in one line, and what it'll do is it will check whatever's directly after the if that turns out to be true, then it will do what's after the then. So this will print the message quitting only if quit equals true. Now I did show as well that true is any non-zero value. So if quit is 1, if quit is -1, if quit is 100, it will yeah, it will you know, it will count as true. So yeah, so you can take that kind of form. The other form, that's sort of like a single line form, but it is correct, and that's what I'm covering here. Is you can have a multi-line form of it, and in that case you get rid of the then, and you have an end if instead. So we can get rid of then. We put end print on the next line, and we indent it because, you know, that's good. and we do an end if there. So so that's basically the same thing. It's you know, it's an identical thing internally. So that's, you know, it's just sometimes it's easier to read, but when you have it in multi-lines, it's much easier to add more things to it. Yeah, there you go. Yeah, that's the old basic way of doing things, was to have it all in one line, and you know, if something is true, then go to something. So you can do yeah. So you can do, so you know, having it on multi-lines means you can add you know, you can have it like a block, like one of the loops, so you have as much code as you want in between the if and the end if. And you can see that I have that down there, so I have you know, two lines in between there. Now what I'm going to do is I'm going to join that back into one line. Oh, we don't need the end if. But there's another thing that's nice about the Ami Blitz editor, is you can do this kind of multi-line editing that doesn't work in SuperTed. Yes, yes, Arabundy, it is absolutely. It's quite key in the 8-bit basics, and especially if you're on one of these you know, 10-line basic competitions, you can't afford to be wasting a line on just an if, you know. You know, you using every single character on that line. That is correct, and I meant to mention that as well. I suppose for compatibility with other basics, and you know, just for compatibility with what people have learned, end if and end if both do the same thing. So, and it's the same with I use end while to end a while loop the other day, and while end while doesn't work, w end does, and they're both the same thing. But I like to do end while, end if as separate words. Just me, yeah, you know, it's just a habit of mine, but you know, it doesn't make a difference in the grand scheme of things. I just like to keep it. I just like to do it that way, you know. It's just a habit. But yeah, there's no benefit to either one. It's whichever one you prefer. And a lot of people do use the shorter version and wend. Yes. Yeah. So yeah. So our single line if up here, and that it looks like that. We can also have an else. Yeah. Well, let's see. I think end if from, yeah. It's just my habit. But yeah. There you go. But you can see we see an else there below. But you can do one thing if the thing is true. If the condition is true, so if quit is true, then quitting. You can also add an optional extra thing, so else. So you can basically, in a situation like this, if the condition isn't true, then it does the thing after the else instead. So if quit is true, it prints quitting. If it's not true, it prints not quitting. And again, that all fits on one line. You can do it a multi-line, and it works both ways. So you do else, and you can start a new block. So it doesn't have to be a single command either, or a single statement, single line. You can do as many lines as you want in there. Now, yeah, Zuberdan did give the ask about the cool mod. Zuberdan did mention else if, and that's in some languages. It is not in Blitz Basic. It's some languages, including some basics, but it's not in this language, unfortunately. So what else if does is it you know, if you put that there, you can kind of, it saves you nesting ifs. You can still do the same thing in Blitz, but you have to do it with separate if command. So you do something like this: if you know, you have to do something like that. But it's what the main sort of, you know, and probably for a gaming point of view, the main use case for this kind of thing is sort of efficiency. So you can do a sort of a, yeah, exactly, yeah, it's a little bit more verbose, let's say, but yeah, it'll compile basically the same way. But if you do this sort of something that looks like if yeah, And so you do score one things there, and you do if, and then and so on. If you're doing something like that, basically, you know, you're getting the computer to check if score is 1 and then do the thing, and then you're checking it again to see if score is 2. But if score is 1, it won't be 2 unless you've changed it in here. But you know, quite often you'll find that that's not the case, and so you want to check that. So in that kind of case, if you do an else there and you indent this, and what that does is it will only check if it's 2 when it's not 1. There you go. Yeah, it's definitely niche, Dan. It's definitely niche. But yeah, there you go. It's funny, isn't it? All yourself as well. All your fault as well. You know, this is I'm doing this in the aid of the Blitz game jam that's coming up. Which we'll give that a shout out, will we? Where's my chat thing? And there we go. There's the link to the Blitz Basic game jam if you want to. If you know, this is kind of what I'm aiming for. Get you set up for this. Maybe do a game. It doesn't have to be a complicated game. It just has to be a game. And and if it's a good game, then it's a good game. It doesn't matter if it's flashy looking or whatever, you know. But so absolutely. So you can see here that you're checking for score equals 1, and only if it's not 1, then does it make sense to check for other numbers, and you can nest them that way. Now other basics and other languages have else if as one statement, and it saves you a little bit of indenting, makes it a little bit neater, but ultimately you can do it that way, and that's an efficiency thing to do it that way. Because there's no point in checking it there. There's just wasted CPU cycles. If score is 1, it's not going to be 2. Kind of makes sense. Now, it's probably a bit of a silly example, really, because if you're going to be doing a lot of that kind of thing, there are better ways of doing it, like a select, which is the same as a switch in C. So we'll do that. We'll do that, will we? So anyway, that's kind of our if then else stuff. Yeah, indeed. It doesn't even have to be a finished game. You get, you get there is a category for judgment on that, but the other categories don't necessarily need it to be finished. But yeah, again, stop me at any point, ask some questions in the chat, have the chats, have the beers. But yeah, so if I think that's kind of clear enough anyway, the if then else stuff. But we can always go back to it another time. And if you have any questions as well, and ask in the you can ask in the Discord at any time. There's a Discord associated with the game jam, with the Blitz game jam, and that's it there. You can join in there, and there's a support section there. Ask all your Blitz Basic questions there, and myself or one of the lads will be around probably. I'm often there, very much enjoying that more than writing reports and work. So so come along and distract me from paperwork. Anyways, speaking of work, Graham is a friend of mine from work. This Graham here that happens to be mentioned, and the reason he's there is because he had a bet that I wouldn't get him mentioned in the in the Amiga magazine, in the Amiga Future. So I did. Got a pint out of that. Yeah, well, yeah, absolutely, and you kind of, especially especially if you're writing a game, like a lot of software ends up being like a state machine, and you've got sort of your software, your game is in one of several different situations, and it's all based on massive if chunks. Well, yeah, it does of course, but I showed you there the other day my tic-tac-toe game, and it's just 90% of it is like massive list of if statements, and all uncommented, so I didn't know what the hell was going on. I'm gonna turn down the happy hardcore for me anyway, because it's very loud in my ears. Excellent. Right. Okay, so yeah, so that's our if then else. Now, a sort of an extension of this kind of situation where you're checking the same thing for multiple different conditions. And there's a whole new construct that you can use instead, and it is very nice. It is called select, and like I said, it's the same as a switch in C. Actually, I'm just going to see if I have an example of this. That's no, I don't actually. I'm sure it's there somewhere. I'm sure it was. But basically, what we're just going to add it in here. So switch looks like, or select looks like this. So select score, and then it ends with an end select. Okay, so that's your start and your end. In the middle of it, you've got case 1, and then you do code based on that. So you do and then case 2. There's no break. It basically the first block of code automatically stops when it reaches the next case. And so you can do whatever you want based on what your score is, and you can do as many of them as you want. You know, case 67. Yeah, it is nice, and because you don't have the break, it kind of comes in useful in C if you want to put multiple cases together, you know. But it's not. You can't do that here. You have to sort of repeat code. So it's possibly a good case for a Go sub, actually. To, you know, if you've got 3 or 4 different cases that need to run the same code, so you can't run them into one another. You know, you can do some binary trickery if they happen to be flags. You know, you can do some binary ORs, but I'm not going to go into that now. But there is a default, and that code happens if none of the cases are satisfied. So and it will do something in there. So we can. So let's run that and see what it looks like. We put that on. No, we put that on. Okay, so it says no quitting, and then I don't know the score because none of these cases were triggered. So now if we do scores 2 and we recompile it, even more points. So it picks one of these, and it'll only be one, either case whatever or default, and you don't have to have a default there either. So if you don't have a default there, you know, you can comment that out, and it doesn't exist. Oh yeah, we'll get that. But if our score is something that we don't have a case for, it just doesn't do any of the steps. You know what? I actually really like the fall through in C. It has bitten me in the ass before. It has bitten me in the ass before by forgetting about it. But I also use it extensively in firmware coding. You know, where I've got like 5 or 6 different conditions, and I want to do this based on that. So it saves doing lots of OR things, and it's yeah, I like it, but I like having the option. But yeah, it has screwed me over as well. You know, so it's a love-hate relationship with it. Yeah, default is a good one. Because often you are in a situation where you want to have a catch-all. So, you know, you want 2 or 3, you know, things, and then for every other condition you want to do something else, you know. So, yeah. Yes, a fall through keyword would be nice. So if 2 fall through, or case 2 fall through case 3, or yeah, that would be nice actually. A nice way of doing it. But alas, 50 years later, we're stuck with it. Yeah. So does that make sense? I think that's pretty straightforward stuff as well. Yeah, I think so. So, and welcome along, Arabundi, again. Yeah, so what I will do is, yeah, I'll draw. Oh, sorry, I missed a question there. Do you do a select on non-standard data types? You can, yeah, but what do you mean by non-standard data types? You can do a select on strings. So you can do okay, well, let's say you can do that sort of thing. Is that what you mean? Or do you mean if a very you can't, well, you see, doing it to the main body of a new type doesn't make sense, but you can do a new type select you can do that kind of thing. That's no problem. Yeah, that's no problem at all. Viscaric. I don't know if that's a good or a bad thing, but thank you. But yeah, so you can use a field of a new type. That's no problem. You can't, if player is a new type, you can't really switch it itself, because what that will be is, if it's just the stem of that, I think it returns the address, and so it's going to look for a case that has the actual address of that variable, and that's never going to be something you can. It's never going to be useful, basically. So yeah, you can use a field of a new type though. Yeah, no problem. Yeah, so like you can also do. Oh no, you can't actually do a true or false, because it'll equate. It will actually check the value rather than just a true or false. So you can't do a positive negative thing. Even and odd. Now what's the like a frame even, if frame even equals true, you can do not really. There isn't a sort of a neat way of doing that, like you're saying there. You can't. There is a way of doing it. Like it's a binary check. So let's do it down here. If you passed a variable into a statement function and you did select on that passed variable, yeah, it doesn't really matter where the value comes from once it's a legitimate value. Yeah, if you can't mix types, as in strings and numerical values, but like a stem or a field in a new type is just a value. You know, that's it. Like, you know, you have to drill down to where it is a primitive value, but it is just a value. So so if you pass player \x into a function, and then, you know, assign that to a variable in there, you can do a select on that as well. It makes no difference. Yeah. So let me see. Yeah, what was I going to talk about? Oh yeah, even and odd. So what we can do is you can do if I pass player chords and chords is a new type. You see, if you're passing a parameter, you're copying that parameter. You're not passing a pointer to that parameter unless you explicitly tell it to pass a pointer. So I tell you what, I'm going to do functions and statements a little later, and I will cover that then. And if I don't, remind me. But I'll get this kind of even odd thing out of the way, and then I'm going to look at some statements and functions and look at passing parameters. No, not at all. It's a very good question, and yes, it does work a little bit differently in some languages like C, where you're pretty much always passing pointers around. Well, yeah, more times than not you're passing pointers in C, whereas more times than not in Basic you're copying the parameters, which is another reason that statements and functions are slow, especially if you're passing strings, because it's very easy to pass a string, but Blitz will copy it. You know, so if you've got a string that's 1,000 characters long, then Blitz is going to cycle through all those 1,000 characters and copy them into another location in memory just to run the function. So yeah, I'll get to that now in a minute. Anyways, right. Ian's question on checking if something's even or odd. There are pluses and minuses to how Blitz handles these things. It is very easy. You know, there's no faffing with stir copy and stir compare and all that kind of stuff. You know, it just works. Like it's very intuitive. But it's very easy to spend a lot of CPU cycles dealing with strings because it doesn't concern you with it. You know, so like in C, you know you're using CPU cycles because you're churning, you're doing the manual labor yourself almost. Okay, right, back to the even and odd stuff. So what we're going to do is to check if something's even or odd, you do a binary check on the first bit, and that's the simplest way of doing it. So simplest way of doing that is to do an and then we'll do so basically what this is doing, this is checking if the first bit is set. That means it's odd because the first bit counts as 1. And so that means it's odd. I will demonstrate this now in a second. I guess. Let's just make sure this works first. Okay, so we're happy with our select and end select. We'll get rid of that. So here's our little program. So score is equal to 5. So I'm just going to make sure this works first. Odd. Yeah, grand. Okay, so what we're doing here is this is the symbol for a binary and a bitwise and. Okay, so we've got a couple of different types of and Blitz does blur between them a bit more than C and other languages do, or some other languages do, and it's part of how it deals with like true and false internally. This one, basically, right. If you've got a binary number, you know what a binary number looks like. So what we'll do is we'll do this bin b string. It does work. So any Blitz has bin b string. So it just says it just takes it as a byte. So what this will do is this will show us what score looks like in binary. Now, so the very last bit, or the very first bit, depending on your state of mind, I suppose, is a 1. Now that counts for 1. So you know how binary works: 1, 2, 4. So so the first digit from the right is worth 1. The second is worth 2. The third is worth 4. The fourth is worth 8, 16, 32, and so on. So we make up 5 by taking a 4 and a 1. Yes, take my bit not. Yes. First, it is indeed. It is bit not, and it is the first bit. Just complicating things. So you see where we're going with this. Excellent, good stuff. I was just trying to figure out how far we have to go back. So the first bit is a 1. And if it's an even number, the first bit won't be a 1. Bit not. Okay, so what we're doing is we're just anding that with %1, which is binary 1. You don't even need that. You can just say it's and 1. But I like to do that just so that I know I'm dealing with a binary operation. And that is, of course, the same as that. So basically, when you do an and with the ampersand, that takes each bit in turn and ands them together. So what you end up with, the result of score and that, is basically 000000001, which is non-zero. If the last bit, if bit 0 is 0, you'll get zeros all the way along, and none of them will be AND, because for an AND, for the result to have a 1 in the result of an AND, both bits in that position have to be 1. Okay, so basically that is how that's the simplest way of determining whether something's odd or even. Does it make sense now? So we'll change score to 10. And we see it's even because the last digit is 0. And so these are all zeros. These end up being 0 because we've got zeros in those positions in the other half of our AND. And yeah, so that's the simplest way. And binary operations like that are actually quite quick to do, because I remember when I was a kid and doing 8-bit programming, the way I did that, the way I decided whether something was even or odd, was to divide it by 2 and see if it was an even number. And of course, that's like, especially on the Atari 8-bits, which kind of they go to town on the floating point stuff. That was so slow. It was brutal. Like, I didn't quite get the thing. Well, you know what? There could be, but it's not something I've actually used. It's not showing up. Oh, even. What does that do? Oh yeah, no, that's a different story altogether. Don't touch that one. That's an interesting one. Yes. Sorry, that is going to be confusing if you're coming from C, because % is mod in C. Mod is mod in BASIC. just to clear things up. Oh, sorry. Bin B string, right? So there is a command in all the versions of Blitz Basic called bin string, and that just converts a value to a string of a binary string. So it's an easy way of displaying a number in binary, and that's all it does. It takes the value. So if you know str string, that converts the number simply into a string, but bin string does that for a number. But it converts it into binary instead of a decimal number. So, and then bin B string does that for a byte value. So it's only 8 bits. So bin string does 32 bits. So you end up with a big long binary number. Like, oh no, that's gonna, yeah, see. So it gives you the full 32-bit number because internally the Amiga does everything 32 bits. But just to make things neat, there's bin B string, which does just 8 bits. And bin W string, exactly. Well, bin string is the same as bin L string, but it might actually exist as well for neatness. Let's see, bin L string. No, bin L string is the same as bin string because an L is a 32-bit, and there's no long. There is no 64-bit. There's a 64-bit float. There's a bin F string, bin Q string, and F string. No. So it's just a byte and a word that are the special ones. Yeah, word will be 16-bit. Yeah, so even is to do with alignment of a block of code. So, you know, there are reasons and situations where you might want your code to align with even addresses. We're not going to be dealing with anything even remotely near that kind of stuff, so don't worry about that. Just doesn't do what you might think it does with regards to odd and even numbers. So, right, so everyone, that's everyone happy with that? There are a lot of times, especially when you're dealing with the OS, where you deal with flags and you're looking for 1 or 2 particular bits in a byte or in a word or in a long word, and it's always good to or it's sometimes nice when you're debugging, especially, to be able to output the binary. No, you can go and shite. I have to see if you're serious or you're just taking the piss now, but I'm going to go with the latter. Yeah. Graham, I'd be very disappointed in you if you don't know your binary dealings. Okay, so I think we're happy enough with that. But yeah, so there are, like, especially if you're opening windows and getting, like, dealing with events and stuff like that, like intuition stuff, there's a lot of stuff where it's nice to be able to output a binary number, or, you know, even internally you can do, you know, it's nice to have a look at a binary, you know, the binary layout of things rather than, you know, rather than the decimal layout. Now, something I will mention here as well. So if you want to express a number as binary, you do a % in front of it. So unlike C where it's 0B, and in C where you do 0x for hex, in Blitz you do $. There is, because this is checking if it is even or odd. So what you're doing there is you're checking if score equals 1 or 3 or 5 or 7 or 9 or 11 or so on. So if you just want score to be 1, then yeah, you don't do it this way. You just do score equals 1. Evening, I'm Immortal. Welcome along. And thank you for the follow, Techman Soul. Techman Soul. Techman Soul. Take a man's soul. Okay. Yeah. So okay. So yeah. So that's what Fryer was asking about there. It was, you know, so if you wanted to check if a frame number was even or odd, or if something, you know, yeah, if any number is even or odd, that's kind of the quickest way to do it. Yeah. Yeah. Yes. So. Right. So I think we're happy enough with that. Aren't we? Are we? Right. Statements and functions. I think I have some ready to go examples somewhere. Loop examples. These are things we've done already. I can't remember where I did them. Oh, reading 3 statements and functions. 3, yeah, statements and functions. Okay, statements and functions. Let's spread this out a little bit. These we were kind of touching on in the chat there a little while ago. The you know, on the Discord. These statements and functions are a nice way of separating out a chunk of your code. Okay, so it's a kind of an isolated island of code, and more isolated than the Go subs that we discussed the other day, the Go subroutines. So we've got basically a statement and end statement, and a chunk of code in between. So it's kind of like any other block of code, any other construct like that. But what we do is we've got statement, and show message is the name of our statement. And after that, we've got curly brackets. They're not normal brackets like in C. They're a special case where we use curly brackets, and that's just the way Blitz does it. So, you know, like it or lump it. Now, within the brackets, you can give parameters to the statement. Now, statements and functions are both basically the same thing. You know, they're both procedures. In C, they're all kind of the same thing, but they're giving different names in Blitz based on whether you want a return value from it or not. Because Blitz is quite explicit about whether something gives a return value or not. There are very few ways to do a sort of an optional return value. Blitz generally doesn't do it. Okay, there are exceptions. If it comes up, I'll get to them. But in general, if you want to return, if you want the statement to do a calculation and give you a value back, then that's a function. If you don't want it, if you just want it to be a bit of code that runs, then it's a statement. Okay, so this statement here is called show message, and it takes one argument called count.b, and b for byte. So that's an 8-bit number, and that's the only argument it takes. And basically all this statement does is it shows this is a message, counter is count, and count is that value that it takes in there, the first argument, the only argument. Now, when the program runs, it doesn't actually execute this code until you call it down in the main body of code until you call it later. So show message, you can see it down here, and we're giving it the argument I, which is our loop. So we've got a little for next loop here, and so I'm going to end down here. So our counter is going to count from 1 to 3, and it's going to each time the loop goes around, it's going to give show message a shout with the value that the counter is, and then so each time it will call this statement and then return back to here and carry on around the loop. So basically we should get that message printed 3 times with the number. This, is fine. It works like that. You can see the word start is first, and that's showing that that's actually there. So that's showing that this doesn't actually get executed until after the loop. So it only gets executed here. But again, you can see the curly brackets here. Oh yeah, no, I didn't want that. Yeah, no, get rid of that. This is in AmiBlitz, or in Blitz Basic 2, you'll get this statement names and function names over here. So this is nice because you can see what arguments it takes without having to scroll all the way back up through your code and try and find it again. And it's nice that it has this in the little list at the side. Blitz Basic has a slightly more sophisticated, or AmiBlitz, sorry, has a slightly more sophisticated browser, but it does the same thing, and you click that and it'll go to the statement. Now, unlike C, you need to have the statement declared before you call it. You get a compile time error if that's not the case. So all your statements can go at the top, or I like to put them all in a separate file and keep them and just include that file. So it's you can do it either. You can have it, but once they're before you get to the first call, then it works. Now you don't have to have a variable there. You can have no variable, and you can just go in here and say like count equals 0. And now when you call it, you still have to have the brackets there, but you just don't include any statement. So we can see there we've got zeros. No, you don't have to save them as a .res. A res, now just to point out the distinction, a res is a resident file, and if you go into the compiler settings, I think it's called compiler options on Blitz 2, but it's basically the same thing. You've got a field here called residence, and you can put a file there, and that becomes part of your program. Now, a resident is like a C header. It can contain a lot of code that's sort of ready to go, but it's already compiled. So you don't need to compile it, and that kind of means that if you use it, you don't need compiling your program is much quicker than if it was the source code. So yeah, so that's good. And usually the residents are used for like mui.res, and that contains all the kind of the values for dealing with the MUI graphic GUI library. But yeah, it's you can add them there, and it that's a resident file, and they're called residents, and they're pre-compiled, so you don't have to compile them every time you hit compile for your program, which is nice. The downside is you can't really debug them very easily when they're already compiled, so but that's it. But to include a file, it just has to be Blitz source. Now in Blitz 2, it has to be Blitz Basic tokenized source. In AmiBlitz 3, I think you can just include a text file and it will compile it. But include will do the job. So like my file.amiblitz3, that's it. Simple as that, and then it will insert that file at that point in the code. Now include, you can do that more than once. And if you do that, the same code, this code from that file will actually appear twice. Okay, so so what I tend to do, and I think what a lot of the AmiBlitz supplied includes do, you do X-include, and that's exclusive include. And if you do that, it will only be included once at the first time it hits that file, and then it won't be included again, which will keep bulk down as well as stopping like things like duplicate declarations and things like that. So you can have all sorts of problems with including the same file twice. If you've got functions in it, you can't use the same name twice and stuff like that. Yeah, kind of, yeah. Yeah, so that's how it's done, and there's nothing special about that file. It's just AmiBlitz 3 source. You can just have the file with nothing except your statements and functions in it, and that's it. Yes, they can. Yes, they can, because I also like to declare all my variables in a separate include, so that I don't have like 2 pages of variable declarations just to tab through, you know, or to flick through at the start of my code. So yeah, so global variables. Basically, it's literally just taking that text and inserting it into your code there. So it's as if it's one giant file, and it acts the same way. Yeah. So, but yeah, it is basically like like the if not defined in C, but yeah, so that that's how our includes work, and it is nice, especially if your code gets a bit bigger, to do it that way. You know, to separate it. And I usually have my, like, a lot of the functions that you wouldn't really need to touch once you've got them written. You know, once you've got them written and completed, just throw them in a file and you leave them there. Now that is true. Debugging is a bit funny, because what it'll do is the debugger, when it stops your program, will just show the error here, where it could actually be anywhere inside that statement, inside in the other file. AmiBlitz does a better job of it, to be honest. It does jump to the file, but yeah, on Blitz Basic 2 you've got it's not great. It's not great at all. So there is that downside to it, I suppose. And what you could do is have it all in the one, and then later on, just to make the project a bit neater, push it across into the includes. Yes. Yeah. Finished code is the way to go, I think. I do a lot of it in AmiBlitz, and it does jump to the includes, which is nice. But yeah, it's not. Yeah, Blitz Basic is a little bit behind there. Okay, but yeah, so we can see that our statement is taking. Let's see, we get rid of that. We had count.b. Now, an important thing to bear in mind is that statements and functions, because they're a completely sort of isolated island of code, the variables in there are specific to there, and that's what's called the scope of a variable. So this is a local scope variable. If I do test equals 5, okay, so I've just declared this variable test.b equals 5. Now if we go out here and do and print test, what do we get? Yeah, we'll get a syntax error because I didn't put the I back in there. Now, see here, our test variable gave the result 0. And that is because that test.b only exists inside there. It is not the same as the test out here. Does that make sense? So we can do 4 just to really illustrate that. We've got test.b equals 3. We compile that, and we get 3, even though in the function has been called 3 times, and it's each time test has been set to 5. That does not matter outside here. So that variable only exists inside that statement. Now, if you want to use a global variable, this is a global variable because that's got a global scope. It exists everywhere except in the statements. Now that can be a little bit different to C as well. So yeah, local scope is a good thing. It is a nice way of minimizing the scope of your bugs, because yeah, if you've got a global variable, you can have a global bug, and the bug can happen anywhere. You know what? I haven't done enough Python to be able to comment on that. I know it's shocking in this day and age, and I have done a little bit of Python, but not, you know, I'm not going to comment. It's mostly been sort of like modifying other stuff, and I haven't paid that much attention. It is something. It's on my list of things to do. I even have Python installed on a couple of my Amigas. Yeah. Anyways, so what I'm going to do here is there's a keyword you can use. Yeah. So basically, yeah, that's what I was going to say. So test is outside these statements. It's kind of global, but it's more. It's only in the outside of the statements. If you get me. So it's not inherited. Basically, is what I'm saying. So it's more like this is your in your main declaration, in your main. Yeah. Basically, that's the same then. Yeah. So I'm going to do that now in a second. So declaring variables in the main body of your code here is like declaring them within your main construct in a C program. So it's not actually a global variable. It's just that the layout is a little bit different. But don't think of it as a global variable because it's not. It's not global in this context. These statements are completely separate. So what you can do is you do shared. Yes, exactly. And you can do shared test. And now, when we run it, now our test variable is 5. Okay, so what we've done is we've imported the test variable into this procedure here, into this statement. So now the code in here does access the outside variable. Okay, so shared is that's kind of useful, especially if you want to import an array into a statement. It's kind of, you can do it with pointers. You can pass a pointer you can pass a pointer and then set up an array and stuff like that. I like to just do global arrays. Yeah. So you can do, and if you want to make an array shared, you don't put in any index or anything. You just put empty brackets, and that's your array shared. So now that player's array will be available to use inside your statement function, which is a handy thing. The other thing you can do is you can put shared here, and this makes it global. Oh no, I'm trying to remember if this is an Ami Blitz thing or a Blitz 2 thing. Oh yeah, you can't declare it. Okay, yes. So there, what you've done there is now if you declare a variable as shared in the outside scope, in the main body of the code, then it's a global variable, proper global, as in all your functions and statements will pick that up. So that makes sense. If you haven't really dealt with statements and functions, if you've only really done sort of 8-bit basic and you haven't done anything in C, this is going to feel a bit funky. But does it make sense? I've seen a couple of examples where people have made a macro for multiple shares. What do you mean? As a macro in Blitz for okay. Oh, so if they want to import like a whole heap of variables, and you're importing them into multiple statements, is that what you mean? So instead of having yes, yeah. Sorry, yes, that is. Yeah, I'll probably get onto macros at some point as well, because they are a nice thing in Blitz. Actually, they're pretty cool because you can even pass arguments onto them and stuff like that. Macros are nice in Blitz. They can be a head wrecker as well, but yeah, they're nice. Yeah, that's true. I don't really tend to do that, but it does make it neater because if there is a chunk of things that you want to import that they are that you do import them all. But I tend to I try not to import too many things, and I'll sort of like only add the variables that I really need in there. So I kind of I like to do it myself. Macros are cool. Like the concept of macro is it's body of code that the compiler inserts into your code wherever you have the macro symbol. So so it's instead of a statement or a function or a subroutine or something like that, the compiler literally copies and pastes your code and sticks it wherever you want it. And so the end result is kind of the code doesn't actually jump around, but if you were to, it's kind of like it's unrolled code. But if you were to do the code yourself, it just makes it look a bit less neat. So it's neater to do a macro, but yeah, I'll touch on them at some point as well. Okay, so so this makes sense. I think everyone's on board with the variables and the variable scopes, local and global and shared. And as I said, you can share a variable or an array by just including it with the brackets. Now you have to be careful if you do a shared and get a typo. Like if you do that, oh, I meant to do two S's. That will probably still work, but what'll happen is you've just created a new variable called test, which is now global. So, you won't get an error for that, if I remember right. Yeah, you won't get an error for that. But now it's a global variable, so you have to be careful of that because it won't warn you that you got it wrong, and it will initialize that as being 0. So you can be scratching your head for a while, wondering where the hell this bug has come from and why this variable is not getting updated, or why it doesn't look like it should. Okay, so just there's a little gotcha for using the shared statement to import stuff. Just be careful with your spellings. And just to illustrate that. We made shared. Okay, we're going to do that test.b. So it's not global. So we can see the test variable is 3, which is what it was before the statement. It's not getting updated in there because we've created this brand new variable. I kind of did touch on them there the other day. I probably didn't do a working example, but yeah, I can do. But yes, you have to be careful with go-tos and go-subs. Or you have to be careful with scope, yeah, because think of this as basically a separate program. You can make little holes into it with your shared variables and stuff like that, and global variables. But ultimately, this is a self-contained body of code. You can't really jump into it or jump out of it. It's not a good idea. Yeah, really not a good idea. You're gonna completely break the poor computer's mind by doing that. Don't jump in or out of that with go sub or go to. But yeah, we did cover go tos in the previous one, because I showed I'm not a huge fan of go to, but there are ways and means of using it and reasons to use it. I had a bit of code where you had to jump over a hook declaration because the compiler would cut it out if it didn't, and there are it's a way of kind of tricking the compiler into keeping the code, even though the code will never be executed. Even though you don't want the code to be executed. So go to jump over a lump of code like that is fine. And sometimes it's just the hassle of not using a go-to is too much, and you just stick a go-to in there. But you just have to be careful if you're in a loop or something like that. If you jump straight out of it with a go-to, it can be basically you can end up building up, kind of losing some of your stack, because when you go into a loop or into an if then or into a select or something like that, the stack gets built up with what the program was doing beforehand, and when you come out of it, that stack gets sort of popped back out. So if you jump out of it, some of that stack gets used, and if you jump out of it again, some of that more stack, you end up eating through your stack, and you might end up having stack issues, which will cause crashes. So and memory leaks as well when the program quits, possibly. So it's, provided you're kind of taking care of that, and there is now, okay, I'll tell you this, there is a way of getting out of that. So the pop command is like, let's say pop select. Yeah, pretty much that's what a stack is. Yeah, basically it's like a scratch pad that's the CPU uses for remembering what it was doing beforehand. So it says, hold that thought, I'm going to deal with something else now, and then it does this little whatever it is, and then it comes back and says, now where was I? And it takes whatever it was dealing with back off the stack, and carries on where it was. Now on the Amiga, the stack is kind of a little bit clunky. Like, it works obviously, and all CPU kind of will have a stack, but other operating systems handle it differently and kind of make them dynamic. On the Amiga, it's fixed, and it's a value that you set in the icon tool type. So it's usually sort of like 1K or 4K or 8K or something like that. But if you use up all that stack, it just keeps on adding to it. So after your 8K, it starts just putting the stack on someone else's memory or in no man's land, and that's when you get crashes or corruption or glitches and things like that. You don't want that to happen. Pop is kind of like if you have an exception or something like that, if you can do it that way, or basically like like exit. Yes, it is. It doesn't do the same as exit. It doesn't fall out the end, so you kind of do need to do your go-to then. You see, so it doesn't automatically, like, so if you're in the middle of a select and you do pop select, the next case, you can pop 4, you can pop 4. But if you do pop 4 and then it gets to next I, and it's the same with the select, then you'll get an error and possibly a crash, because it'll try to pull whatever it was dealing with off the stack and it's not there anymore. So just be careful of it. You have to say, so you put a label there, say end of loop, pop 4, then, so let's say, do a full example. If I equals 6, pop 4, we also pop the if as well, because we're jumping out of the if, because you don't want to leave an end if hanging there. But you have to do that. You have to go to, because if you don't do that, what happens is you've popped out of those, now it hits an end if, doesn't know what the fuck to do. Like, why have I got an end if here? I'm free of my if. I'm free of my 4. What the hell is this next about? It doesn't, you have to make sure you keep your nesting in order, keep your wits about you when you're doing that, because that's trying to pull non-existent stuff off the stack then, and you're going to have a bad day. Does that make sense? I don't condone this sort of behavior, but I know there are situations where it kind of makes sense to just do it that way, because it is neater and simpler to do it that way. But I prefer to use a kind of a flag system, or that's it. But yeah, that works, and it is a reason to use go-to, is if you're going to do that kind of thing, you need to do it that way. Well, you can pop an if, a 4, a select. Let's see. Let's pop. There you go. Go sub 4, select if while repeat. It might do, yeah, it might do. What I like to do is if you're working through something like that, if I equals 6, then instead of popping and going to, I will just do I equals 10. And that pops it at the end of the loop as well. So, you know, you found what you need, and then it doesn't iterate the loop anymore. But, you know, horses for courses. You know, you go nuts, like I said the other day. I think, you know, ultimately, if you go into assembly language, everything's a go-to. You know, there's no real kind of statements or functions or none of this, you know, nice quality of life stuff. You know, you're jumping around. You're literally jumping to addresses. That's, you know, that's how it works. Everything's go to this, go to that, or go sub, I suppose. But yeah, so see this number, make it be there. Yes, exactly. And because I is just a variable, you know, it is, you know, for loop is kind of a semi-magical thing, but it is just a variable. If you make that the same number as that, then that's the end of your loop. Just beware of doing that, and this has caught me out before, is doing that and then changing the loop to something bigger. So it doesn't end up skipping to the end then. Yes, but yeah, that's how I do it. Everyone has their yeah. Yes, exactly. Yeah. Yeah, and then you can return from that. But yeah, so that you can do go tos and go subs, but that's kind of the extent of it when you're doing an assembly. And a lot of like a loop, everything when you're looping is just a jump or whatever, you know. Okay. So yes, but yeah, so I just touched on something there. If you type in a command, and it's the same for Blitz as well. If you press the help key, and I should have covered this very early on, if you press the help key, you get your parameters up here. And so this is kind of telling you that it should be one of these. So the bar means or, and it's the same thing used for that. Yeah, it is handy. Pop go sub 4, select if while repeat. Now, if you're not using the very, very simple Blitz 2 editor, if you're using SuperTED or you're using the Amiga Blitz 3, you can press Shift and help, and that opens the page. Oh, it opens the help page for it. Now this is interesting. Pop is only necessarily to prematurely terminate go subs, 4s, and selects. If, while, and repeat have been included for completeness. Okay, so there you go. So you don't actually need to pop the if. Every day is a school day. But yes, there you go. They're just there for convenience and for neatness. Okay, but you do need them for go subs, 4s, and selects. Yeah, because if you get a return, yeah, so yeah, it's why you would want to do that. I can't think of a case where you would want to do that, but I guess they exist. I think, yeah, for sure, yeah. Because if you, and I think we touched on that the other day as well. Yeah, if you return early in the go sub it errors. Yes, yeah, and if you kind of get to the end of your program, you don't have an end, and it starts executing your subroutine. When you get to the return, it craps out, and you get yourself a crash. So, but yeah, not that should be how it works. Not that you should be falling at the end of your program and going through your subroutines. That's not a good idea. But yeah, there you go. It works for go subs, 4s, and selects, or it's required for go subs, 4s, and selects. There you go. Yeah, that shift help is quite nice because it'll jump to the right page of the help file. Good for you know, yeah. Let's see, statements. You know, it is quite good. Yeah, there you go. So, I think we're okay, are we, for that? Yes. So yeah, but yes, you're right. There's no excuse or no reason that you would want to, or no reason you should go jumping in or out of a statement. It's bad news. Don't do it. Simple as that. Now, I'm going to have a look at functions now, and you remember functions are the same thing as statements, except they give a return value. So, oh, here we've got some terrible indenting. Don't know who wrote this. So we've got a function, and you can see here that we actually declare the function like we declare a variable. So we've got a .w, and that means we are returning a word variable. So we have to say that because this is what the main program will look for, and it will be returned as that variable. So you have to tell. So if you don't do that, it will return a quick, and you don't want to use a quick unless you need to, as I said last week or last time. So function.w to tell Blitz that you're returning a word variable or a word value. So calculate score. You take a factor, it multiplies the factor by 25, and then you've got this extra line here, function return score. Okay, and that just return, that basically ends your, it won't return a quick. If you, oh, well, no, what do you mean by def type W? Oh, so score.w. Yes, it will return, it will cast the W to a Q. It will cast the word to a quick and then return a quick. But the quick won't have any decimal part. So it will okay, if you do a sorry, yeah, if you do a def type.w, is that what you mean? Yeah, if you do a def type.w, then these will all be .w's by default. Sorry, yes, that's correct. Yeah, so yeah, if you do that, you don't need to do .w's on these. I like to do a function anyway. I like to do it anyway, just for, just so just for my own sake, so when I'm looking at it. Oh, no. But yeah, I like to do that just so I know what it's just, in my mind, what's going on and what's expected of it. But yeah, that's you can't actually do a help on that. I thought you could, but anyways, yeah, you can def type it there, and it will default to a word. Yeah, that's the default, I suppose. Yeah, that's it. But I like to declare it anyway. So that's telling it that you want to return a word variable or whatever the default is, and it will return that. So you really, if you have mismatched between that, it will cast it, and Blitz automatically casts everything. It doesn't tell you that it's casting. It doesn't give you an error if it's or a compiler warning, like it does in C. So it silently casts everything. Yeah, so you just be careful with that, because you might it has caught me out as well. But yeah, so this takes your factor, which is a byte, and multiplies it by 25 and gives the score in value in word, and then returns that value as score. So down here we've got result.w equals calculate score, and then we print that result. You can also just end print calculate score, and it will do the same thing, so we kind of know what we're expecting here. We're expecting our 25 times tables, 25, 50, 75. Yeah, so that's fine. Yeah, that makes sense to everyone. So basically, this function return, you can have as many of them as you want. So you can exit the function there. So if but you should always have one. You should always have one. So you should never allow a function to end without returning a value, because you might return a null pointer, and that's bad news. So yeah, basically you want to always return that. But this works for statements as well. So you can do statement return if you want to finish a statement early, without running all the way through the whole statement. You can jump out of it that way, but yeah, you can do it with a function, but you should always have a, you know, if you don't have anything else, just do a function return 0 just for safety. You know, if you're going to be jumping back with the score or whatever, just do that so that you don't cause any problems. But yeah, so the functions return the value, and otherwise they're exactly the same as statements. They've got the same kind of scope, the same limitations. Does all that make sense? What I didn't touch on before was you can include more than one parameter, and then you have to put a second parameter in here as well to pass the two parameters. Now, yes, so what I was talking about earlier was that these variables are copied into the function. Okay, so when the code gets to here, calculate score, the variable I is copied into the factor.b and cast if necessary. So, you know, they're both bytes here, that doesn't matter, but let's say that's test.l. That will be cast to value.w and copied over to that. It won't, so the function, anything you do to the variable value doesn't affect test in the outside scope. Cast basically means it's converting between the types. So it's basically sort of treating one as another. So in C, it's kind of an explicit thing that you need to do, but Blitz does it sort of in the background. So, you know, if you've got a variable and it's a byte variable, it goes up to 128 or 127. If you cast a word variable to that and the value is 100, then the byte value will be 100. But if you cast something like 200, the byte value will lose the extra bits off the end, and it just basically does a best guess at what it can do. Let's do some examples. Num1 dot byte equals 100. Now, do you see what it's doing there? So it's taking a byte value and it's copying the value into the num2 variable, and that's casting it. So it's taking the value of num1 and saying, okay, what's it gonna do there? So this will work obviously because a word is bigger than a byte. Num2 is 100, okay, but if we do that the other way around, that will still work. So it's 100, but now it's a word variable, it's 1000, and we get minus 24, okay, because it's wrapped around, and it's wrapped around several times. So all you've got is the binary, the rightmost 8 bits of the binary have been transferred over, and that's where casting causes problems. So you have to be careful with that. So that's kind of a brief thing. Now, AmiBlitz can also let you do things like casting strings to longs and other things like that. There are commands for doing that in Blitz 2 as well, but they're not. It's kind of an explicit command, it's an explicit statement. But when you're casting a string to a long, it takes the ASCII code of the string of the characters and puts them in each byte of the long word. That's useful for some things. It's a bit funky, but you can cast strings to values as well. Yeah, but basically that's what casting is. But yeah, you just have to be careful with it when you know, because you don't want to call a function and the value end up being completely wrong because you've mismatched types. If Blitz can do the conversion, it will do it, and it will do it silently, so you don't know it's doing it, and yeah, you want to be careful. Okay, this makes sense to everyone? I'm going to take a quick beer break, and I'll be back in a second. Think up some questions. And I think we'll do. Were there any more kind of? These are basically fundamental programming techniques that we've been doing. There's foundation, and any kind of you kind of need to know these things to do literally any kind of software. But or they're useful to do for pretty much any kind of software. Yeah, I think I'll do a little bit on graphics or something like that now after this. Nice, good job. But yeah, I will be back in a moment. And no, it's the thing is that it's yeah. Sometimes these are kind of like niche concepts, I will. Oh yes, I will talk about overheads. Yeah, day job code is boring, and you know what? I love coding, and I love coding firmware. In my old job I did a bit of firmware programming, and it was it was fine. I really liked it, but it's part of the reason I use Blitz on the Amiga so much is because I was doing that in C and not C++ range, just straight up C. Oh, excellent, well done, and all working again. Good stuff. But yeah, so I was doing like standard C, kind of the same stuff you would do on the Amiga, and it's a similar kind of idea. You've got limited memory, limited stuff. You have to be careful with your pointers, and everything's a kind of a tight memory map. And then I'd come home and I don't really want to program in C. And Blitz is like it's different enough that it's kind of like a different a different language. It's a different language. It's like a different hobby, as such. So I really like C for that. But anyways, yes, I'll get some snacks and I'll talk about overheads now in a minute. Yeah. I did a bit of C# in my old job as well. No 3D Studio Max, so nice. What is your job, actually? If you're allowed to tell us. because I design medical equipment, and so currently my job, it doesn't have any programming. It's kind of sadly, but you know, it's sort of like low tech stuff. Oh, I see. Very good. That's interesting, and the penetration stuff's good as well. That's cool. Good stuff. That's serious kind of software. Yeah, I don't have any software or, you know, electronic stuff in my current job. It's all kind of low tech stuff, materials engineering and technology. But my last job, I was well, we were developing lab equipment for hospitals, and so they had a lot of basically they were very complicated machines made up of lots of simple modules, and that all talk to each other, and there was a central kind of command computer and stuff like that. So it's like each of these modules, like a robot arm or a sensor, had you know, a firmware module on it. And no worries, thanks very much for coming along. And yeah, sure, this will be on the video on demand, and it'll be on YouTube at some point as well if you want to catch up on the rest of it. But yeah, so that was the kind of firmware I was doing. It's like, you know, sort of like pattern detection and stuff in small, you know, small modules, or, you know, like in robot arms, that kind of stuff. But occasionally I was doing the user end software as well, like for running on the PC, and that was either in Delphi or C# most of the time. I did a bit in Visual Basic as well, just like kind of my own fun stuff. But yeah, so that was it. Kind of missed those things a little bit. Anyways, so did any questions come up? Yeah, it's nice. I was never fully on terms with it. I probably didn't use it enough, because I used that because there was one program, you know, program that did this analysis on the waveform, and it was written in Delphi, and I had to update it loads of times, so it kind of became mine. But it was yeah, I didn't spend enough time with it, I suppose, but it was nice. What I did was nice. Yeah, I don't know if it would be my first pick. But in 2001, I was in uni, and we were actually doing we did a bit of 6809 assembly, and x86, and we did a lot of C stuff. That's a scary thought, isn't it? Oh yeah. Yeah, 21 years, Jesus. Yeah, because I graduated in 2003. But I distinctly remember being in a class, and kind of, you know, we had this like 3-hour lab, and everyone had their sort of 6809 developer board. And it's one of these things you can punch in hex codes and, you know, get to turn on and off some lights, and it was that kind of thing. But by the end of 3 hours, like, you know, people had, you know, said like, oh look, I can make this light come on, I can make this light come on. I had mine playing the Simpsons theme tune. Yeah, so it was yeah, I got myself a bit of a reputation. Anyways, right. So overheads, yes. Now, calling functions and statements, because they are essentially like a separate program, there's an overhead involved in calling it. So if you when the compiler gets to here, it has to go and it has to go and jump into the function here. I did say earlier on about the stack. We were talking about the stack. All the things that are going on out here have to get put on the stack, and then it sets up a whole new, like all the registers, all the CPU registers that are being used in the main program. They all have to get pushed on the stack, and then you end up with a whole new context here. And so these variables are set up new. Basically these variables are set up new. And when you set up a variable new in Blitz, it's automatically initialized. And every time you do that, that takes CPU time as well. Because it's not like C where it just comes up with a value, or where it just like basically sets up the variable, assigns the RAM for it, and you get whatever garbage within RAM. Then it actually sets up the variable, allocates the RAM, and then writes 0 into the variable, and that can take, that takes several cycles, So it does that for every variable that's involved. You have to take that into account, and then when you exit, you have to restore all the registers as well, so read them back off the stack. There's quite a lot of overhead involved in using functions and statements. Doing a go to or a go sub, you don't have that. You don't have that overhead. So a go sub is a reasonable kind of solution for when you're doing really time critical stuff. Now, when I say it's slow, like, you can still use functions, but if it turns out the function is slowing down your program too much, then you might have to jump and change to a go sub, and that will get you a few extra CPU cycles. It's not magic, If you're that tight on CPU cycles, you're probably doing an awful lot, but yeah, it's worth bearing in mind that you've got these the convenience of having local scope variables is paid for by the speed of it. Now, yeah, whereas a go to and a go sub, there's very little. A go sub is kind of like one value is pushed onto the stack, I think, just your return address, and that's it, which is kind of like basically 1 or 2 cycles. Absolutely, that's it. And I tend to use statements and functions where I can, and then only use go subs where I know I need to. Yeah. And the thing is, if you're caught, the only way it'll really sort of have a major impact on performance is if you're absolutely on the limit of the machine, or if you are calling thousands of them a second, like dozens and dozens of functions or statements per frame. That's where you're going to start noticing things. Now, AmiBlitz has a fast function. Okay, and you declare that by putting the fast keyword. How do you do this? Why is that not showing up? Oh yeah, it still compiles. Yeah, so using the fast keyword, I don't know why it's not highlighting it. Basically, take some shortcuts. And it means you cannot use strings or arrays within the function. Your variables aren't zeroed, so they're declared but they're not zeroed, so you do get nonsense in them, but it is a way of running a statement or a function much quicker, and only AmiBlitz 3 can do that. So Blitz Basic doesn't have that option. But yeah, it's something. It is useful if you're going to be calling it a lot per frame and you still want to keep the function or the statement aspect of it. Excuse me. But yes, the overheads, especially for if you were to pass a string. If you're to pass a string, so I was saying that each parameter is copied over. So each parameter is copied over in RAM when you start your function. So in this case, the value of I is copied into factor.b, and the value of message string is copied into text string. Now, that looks nice and neat, and it's all very easy to read, very easy to follow. That costs a lot of CPU time because every single one of the characters in that string is a byte that needs to be copied over. It's a value. So you could have 1,000 characters in there, and that means that your CPU has to copy 1 kilobyte of data around RAM every time you call that function. If the string is that long, you know. So just just bear in mind that the convenience comes at a price. I'm not going to cover passing pointers to functions or statements at the moment because I want to cover pointers and statements in general some other time. And yeah, they can be a bit tricky to get your head around. Yeah, so you do get a bit of a bonus when you are using Go subs, because it's all the variables are in the same scope. They're in the global scope effectively. So you don't need to do any of that copying and stuff like that. It just stores its return address, jumps to the address, does its thing, and goes back. So yeah, there's a big time saving there if you're in the business of counting cycles. So, shall we have a look at some graphics? I think it's one cycle. I think all it does is push, it's a couple of cycles, but all it does is push one value, it's the return address, onto the stack. And that's it. And when you hit return, it pulls that address off the stack and returns to it. Well, I mean, if you're short of one or two CPU cycles, you're in pretty dodgy territory, to be fair. But yes, yeah, keeping it in the main loop will stop that. But the problem is, where it comes into its own is if you need that same code in more than one place, you can go sub from multiple different locations. Whereas if you have it in your main body, your loop is longer. And that causes its own kind of issues. You know, that might cost you an extra couple of CPU cycles if you can't do a near jump. You know, if you got a long body of code. So yeah, it all depends on, you know, what you're doing. But if you're that tight for CPU cycles, I think, yeah, you're doing some impressive stuff. So don't expect miracles from this. You know, if your game is running at 1 frame per second, don't expect copying stuff into the main program loop to suddenly give you 50 frames a second. You know, it's not. These aren't the kind of speeds I'm talking about. Yeah. Yeah, structurally, if you can keep separate chunks of code that do their own little job together, you know, out of the way, and get them with a nice little name on them, you know, a little name that shows up over here, that's the best. Okay, shall we do some graphics? Or do we have more questions on statements, functions, or anything so far? Graphics it is. The people have spoken. The person has spoken. Okay. Yeah. See, when I did these tutorials for Amiga Future, I did the basics, then I did GUIs, GUIs, and deal with intuition stuff first, and then I went on to other stuff. But for now, oh, where did the graphics come into it? Listing 7. Ooh, we've gone too far. Let me look at listing 5. What does that look like? No. Next one. We're still looking at Windows stuff. There's some This is nice here. Just as an example while I'm here, nested selects. So this is a typical kind of event loop, but you have your select here, and we're checking a couple of different things. Oh, these are constants. Constants are used in Blitz, like in C, as a sort of a substitute for an actual number that never changes during the program running. So the compiler, just wherever it sees a constant, just sticks in the value that you want. These values come from the operating system includes, which are resident files in Blitz. And but they just make the code a little bit neater. But it's literally just a value, but because it has the hash symbol in front of it, that makes it constant in Blitz. And you can declare them like hash my constant, and it's as simple as that. Yeah, string constants. Yeah, it's kind of a case of just using a variable, I suppose, you know. But yeah, string constants I think would probably come under a macro. You could use it. You could use a macro to do them. Actually, I've never done that, but I just declare a variable. But yeah. Yes, welcome back. But yeah, I loaded this program just to see what was in it. But yeah, constants it's just substituting in a number, because it makes the program a lot easier to read, especially with these kind of numbers, because these are big numbers. They're big hex numbers that really have no meaning on their own. Yeah, exactly. It does what it says on the tin. But instead of being a variable where the computer has to look up the value and load it into RAM, the compiler literally inserts that number into the code when it compiles it. You know, so it copy and pastes the code. Exactly. Constants. I'm a big fan of constants instead of magic numbers. Says me with magic numbers down here. But yeah, that's fine. You know, it's kind of fairly. Those ones are fairly self-explanatory because you can hit help and have a look. But yeah, it's simple enough. But anyway, what I was going to point out here was it's got a repeat unto loop, and then inside that's got a select construct, and inside that it's got some case bodies constructs, and then it's got a whole other select up here. Yeah, they will. But yeah, so that's just showing you that you can nest kind of you can nest these things. So this is basically when each one of these is like a sort of an event, like close the window, or someone presses a gadget, or the window is resized. This is when the menu is used. This one triggers, and then you go into the here and you choose which menu was hit. You go into it, nested again, which item was hit, and yes, it's it's dark magic. Yeah. But yeah, so here, you know, because I've only got two menus involved, and it's kind of like, yeah, we just declared them earlier in the program. Oh yeah, there's pointers and everything in there. This is yeah, so this is kind of just shows you. I tend to use numbers for the menus because they're just literally like menu 0, menu 1, menu 2. But where you've got these are flags, and it's the same thing, constants that the operating system declares, and the same with up here. These are operating system declares constants. It makes it a lot easier to deal with. And yeah, and the window here has flags, and so you see some people, and I did it back in the day, I load up old code, and this will just be like a hex code of like, you know, 14B8 or something like that, you know, and that's like yeah, that's kind of not, it makes no sense whatsoever, but having the flag names is there. Yeah. Yeah, and I tend to for a lot of things. Yeah, it is a bad habit of mine there to do this, but where I've only got one of a thing, I tend to use just zeros and stuff for that, and where I access things with a variable, I tend to use just a 0 as well. But yeah, generally use constants, and I will declare my own constants as well for objects. But yeah, that's not the file I was looking for anyway. tutorial 5 example. We need to go on to tutorial 6. Hey! Here we go. Graphics, and we were having a discussion about RGB earlier as well. This is all good stuff. Now, oh, we have a statement in here as well. Look at that. Now, see what I've done here. And this is a good use of a statement, and a good use of, you know, showing you that when you're using the same bit of code multiple times, it's like good to have it separately instead of inserting in the main body of code. So what this code is doing is it waits until the joy button for port 0, which is actually the mouse, is non-zero. So when it repeats it until it's true, and then repeats it again until it's false or 0. 0 means no buttons are pressed. Okay, so what that means is it essentially waits for the button to be clicked and then let go. Either mouse button or both. But that's it, and it's contained in a statement in the middle of this loop. Exactly. So it won't work if the button's already pressed, and that's kind of like the point of it. Exactly. You have to click it down and you have to release it. So it's a neat little thing, but it's very simple. And what I have in here is a V-wait. Now, V-wait isn't ideal, but it's what V-wait does is it stops program flow until the next time you get a vertical blank. Now, vertical blank, you know, from CRT days, is when the beam gets to the bottom of the screen, it stops, goes up to the, oh, where's my finger? Stops, goes up to the top of the screen, and it starts drawing again. So, you know, it does that again and again and again, and every time it gets to the top, that's your vertical blank. Okay, so this where the beam's doing this business, that's your vertical blank. Now, on the Amiga, even if you're using an LCD monitor, or if you're not using a CRT, the graphics are still drawn the same way. It goes, you know, left to right, top to bottom. So each line by line by line by line by line, and then it stops, goes up to the top, and you've got this little pause every frame, and that is a good time to do stuff like flipping bitmaps, because the screen isn't being drawn, no extra graphics information is being output, and so when it starts drawing, it will have the new bitmap ready to go. For example, will this halt VBlank interrupts? It doesn't halt them, it actually is one itself. Basically, it sets up a vertical blank interrupt and waits for it to trigger, and then carries on. Actually, no, it doesn't. No, this is what I was going to say. Sorry, a V-wait busy loops and waits for the vertical blank to trigger. So I don't know exactly what it's checking to do that. But it busy loops, which is it's not ideal, but it does allow the multitasking a certain bit of room to breathe. So if you didn't have the V-wait in there, it would do repeat until that repeat, and that would still work, but it'll hammer the multitasking a lot more than when you put in V-wait, which gives it a certain amount of leeway. So it doesn't actually go near the vertical blank interrupts. No, it won't. So what you'll do is your interrupt will fire once a frame as well as your main loop or whatever loop that V-wait is in. But yeah, it does busy loop, which is not ideal when you're in operating system friendly mode, which is what this program is. Okay, so statement pause, now V-wait, and then V-wait. Okay, there is an alternative, and that is delay 1. Now, what delay has the same timing as V-wait, but it waits. I'll do that instead here. But what, instead of V-wait, which busy loops and constantly checks for the next vertical frame, delay is an operating system call, and that's why it has an underscore after it, because that denotes that it's actually a direct call to one of the operating system libraries. Okay, and you can see at the top there it's actually saying dos.library. So this calls the delay function from dos.library and with the parameter 1. And that stops the program flow for 1/50th of a second or 1/60th of a second on an NTSC machine. So it's probably a little bit longer than VWait really, because it waits for a full frame to go by, not just until the next frame starts. There is a there is a horizontal blank. It is much shorter, as you can imagine, because it's in the nanoseconds rather than microseconds range. But yes, as the beam goes across, it stops, it comes back, and that is used. That vertical blank or that horizontal blank is used for things like updating the pointers in memory for the chipset. It's also used for getting the details of sprites and things like that, and whatever basically needs to be drawn in the next line, that gets fetched from memory. All the pointers to them get set up, and that basically sets things up for the next line to be drawn. So that's your horizontal blank. There isn't a horizontal blank wait because the horizontal blank is so short that you wouldn't be able to do anything realistic with it in BASIC. It's just, you're really talking very, very tight stuff. But yeah, it can be worked with. But yes, yeah, it can be. The horizontal blank is basically it's more used for internal stuff. It's used for this. It's used for a lot of DMA stuff, like so the Paula DMA, the Blitter DMA, the Copper DMA. They're all done in the horizontal blank. There's not a lot of breathing room there to do anything with, other than maybe getting the copper to do things. But yeah, it does exist and it is a thing. It's just not really of significant use for, unless you're doing really, 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 really serious stuff. It does come into play, when you're dealing with sprites and things like that. That you actually have to understand that there's only so much time in the horizontal blank in the fetch window, and if you don't get your stuff ready in time, then you either lose some information. So what typically happens is if you have your screen that's too wide, the beam gets to where it has to draw the next lines before the last sprite is loaded, and then you lose sprite number 7. It just doesn't show up. So there are situations there where it does actually impact on what you're doing, but it's not something you can really control. You can just deal with it. You can. You can't really. You can't really do that in your main program as such. You can. The timing's so tight that it's very difficult to do. What you do in the Amiga generally is you set up the copper to do something. So you tell the copper. Yeah. Yeah, that's it exactly. But on the Amiga, what's more normal to do is you tell the copper to do a certain thing at a certain horizontal count, and then it'll do that. But even that only has a resolution of like 4 pixels or something like that. So to do one copper instruction, like a copper instruction can change a palette entry or something like that. So you can get the copper to hit a certain point, let's say a pixel 128, and it will change one color register. But because the beam is so fast and the copper can only do one of these per 4 pixels or something like that, you can't change the whole palette. You change one color and then the next color and the next color, and that's 12 pixels gone by. So you have to be careful. It's very tight. It is doable. It is very doable, and you can use it for all sorts of awesome effects. But it's a very precise, very tight thing. Yeah, that's it. Hey, Francis Leo, welcome along. Francis Lilly, sorry. Welcome along. Thanks for joining in. But yeah, it is. That's the domain of demo coders and stuff like that. That's really where you're going with that kind of stuff. You can. It basically involves, if you want to do horizontal stuff in Blitz, you can either use the Blitter to do it, like horizontal scroll splits, or you need to set up the copper by hand, and you need to basically sort of be familiar with copper programming to do that, copper coding So you need to write a little program for the copper that changes the bit plane pointer halfway across the line or at a certain horizontal location, and then you enter those commands into the cop list. Yeah, basically you can modify your own cop list, and there are instructions for that. The custom cops command, I think, lets you give it a string, which is actually a string of hex values or of binary values for copper instructions, and you insert them into the cop list, and then that tells the copper to trigger to fire at a certain XY coordinate and do its job. And if you change the bitmap pointer then, or the bit plane pointer, then after that point on the screen it shows the other bitmap. But of course, because you might have 4 bit planes involved, that can take 12 or 16 pixels to do as well, because you have to change 4 or 5 different pointers. So you end up with a sort of a gap in the middle that you have to kind of paper over. And usually, I think the likes of Lemmings uses a column sprite to do that, to basically cover over what's going to be an ugly mishmash of the old and new bitmaps. Yeah, it is doable. I've never actually done it myself in Blitz, but yeah, I've never done a full stop. It's not something that I've gone into, but it's a bit involved. Exactly. It's the very same thing, but instead of like 3 lines, it's going to be like 12 pixels or something, because the beam is so quick. And in those 3 lines on a horizontal change, you're changing a lot more than just the bitmap pointers. You're changing the palette and everything, like so. Yeah, you got a lot more time on a whole horizontal line. You know, you got like a couple of microseconds there instead of like the pixel clock is like 70 nanoseconds on the Amiga, so like for a normal resolution. Oh, no. See, that's a different thing. Actually, sorry. There is a different way. I see what you're saying now. You can get a separate bit plane, but what you want to do then is you want to do it at the start of the display. You don't want to split it halfway across the screen. You want to do it at sort of position 0, basically. You want to load a different bit plane pointer into one of the bit plane registers and effectively create a new bit plane for that. It's still done the same way, but the timing is a little bit more forgiving, I suppose, because you do it when it's not actually being drawn. So no, yes, sorry, yeah, I remember that conversation now. Yes, yeah. There we go. Anyways, right. So I have this pause function here. Yeah, sorry. Yes, I see where that was coming from now. I see your thought process. Yeah. No, you have to do it manually, basically. As in put the code in the cop list. But that's kind of I think that's what Agony does. I think, you know, for the moon in the background, that's a single bit plane. But if you check out the Code Tapper's website, that has all the really cool information on that stuff, and some of it's really fascinating what they do. But yeah, okay, so we've got this statement here. So that basically waits for you to press a mouse button and then release the mouse button, and then it just returns. Now we've got a few different things here, so there are a few concepts to bear in mind. Oh yeah. I'll have to check that one out. So a few new concepts. So what we're going to do is we are going to set up an intuition screen. So we're doing it's a mixture of system friendly and hardware banging stuff here. Okay. So it's system friendly in that we're doing all this, you know, kind of in a system legal way. The operating system's still running and stuff like that, but we're not using the operating system to actually do the drawing. We're accessing the chipset directly. So that's why these commands are highlighted. AmiBlitz will highlight these to warn you of that. So these purple looking commands, they're all banging the hardware, and they won't work on a graphics card or won't work on, you know, a next gen Amiga that doesn't have the custom chips. Basically, that's it. So we're doing a bit of setup here. So the first thing we're doing is we're setting up a bitmap. And if we go and we press help here, so we're seeing this is bitmap 0, but we're making it 1024 pixels wide, 200 pixels high, and the depth of 5 means it's got 5 bit planes. That is 32 colors. Okay. The next thing we do, plot, is you'll remember these commands, I suppose, from your 8-bit basics. But plot and line kind of do what they say in the tin. Plot is a single pixel, X, Y, and color. So plot a 10 and 20, and color 17 random number. And then line draws a line from the first point to the second point. Now, if you look at the help on this, where you see square brackets like that, they're optional parameters. So if you don't include two sets of coordinates, x1, y1, and x2, y2, it will draw from the end of the last plot or line command. So wherever it was. So you can just add extra lines onto the end of the previous line by doing that and to connect them. You know, like if you wanted to draw, let's say, draw a square like that, only the first line needs to have two sets of coordinates, and then the next one just has to have this coordinate, the next one has this coordinate, and the next one has to have this coordinate. So that, you know, you can do that to do a continuous line. Circle fills a circle, so 100 and then that's x and y coordinates, 100 by 50, and then again the last parameter is a color. Now OR(x) is the radius in the horizontal radius. If you don't include a separate OR(y), it will just draw a circle. If you include a separate or radius y, you will make an ellipse, and it will have, you know, 40 pixels and 20 pixels or whatever you want high. Does that make sense? It'll actually make a diameter of 80 pixels circle basically when it's left like that. So we're not including the OR(y) parameter here. Now the next command is the screen command. This opens an intuition screen, like a normal screen like this. So you can pull it down, you can see workbench will be there. And it opens the screen. Now this is kind of a complicated set of parameters here, but there are two ways of doing a screen, setting up a screen. The first has one set of parameters, just 3 parameters, and it kind of does a bit of autopilot. And the second gives you a lot more control. So that's what we've done here. But the first number is a screen ID. Now this is an ID you give it, so you can give it any number you want really within reason, you know. But usually, you know, kind of 0 for the first one. Yeah, you'll find there are quite a number of commands that actually have sort of an easy and a hard, or, you know, sort of novice and expert mode, you know. But yeah, in Blitz you got a lot of objects actually, and I should kind of go back a little bit and talk about that. So Blitz has a sort of object orientated feel to it. It's not fully like C++ or anything like that, but it does deal with objects in quite a nice manner. So when you create an object like the bitmap, you give it an ID number, and I've given that one bitmap 0 and screen 0. So the 0, like, you know, you can have a screen 1, screen 2, screen 3, and you can have bitmap 1, bitmap 2, bitmap 3. They're unrelated if they just share a number. So what we're doing here is we're setting up a screen. We're giving it the ID 0, and we're saying it is x and y and width and height. Now x and y are kind of like, you know, where the screen is set up. It's actually kind of set up at 100 across. I can't remember exactly what my thinking was here. But anyways, width and height, you'll see there, match the bitmap. Okay, so if you're going to apply a bitmap to a screen, you kind of want them to be the same size, or you're going to get either garbage or missing, you know, you're wasting memory or whatever. But there are reasons why you would want to make the bitmap bigger, you know, so you can scroll around it nice and smoothly. We might deal with that later, but for now we're just going to make the bitmap and the screen the same size. So width, height, and depth are all matching. So again, 32 colors. And then View mode. Now, if we go into the documentation for view mode, we'll see what that means. You've got a load of options here. This is actually a bit funny. But basically, low res is 0. Okay, so this is after falling off the line. So if you just imagine that was up there. But basically, a low res screen is 0. So that's your basic low res screen. So you make it high res by putting these values in. Now these are actually binary values. So they're actually binary flags, and you can make it up with flags. Blitz, especially the Blitz manual, is not very good at doing this, and it tends to throw the magic numbers around even more than I do. It's pretty bad for them. But yeah, they're binary flags, and you can use the operating system flags to set up a screen like that. Hey! Nag Graham, how are you? How are you, my good friend? Welcome along, guys. Welcome along. Hello, Vagarius. So Graham, what was the story? What was your stream? You were doing CD32 things tonight? Oh, thank you. Thanks for the follow. Hey guys, we're doing a lot of Blitz Basic. We were just starting graphics. So we've done our basics, forgive the pun. So we've done all the kind of like, go-tos, go subs and stuff like that. So so now we're getting into the actual kind of, now let's do something with this stuff. Yes, the Kiwi's Tale. Yeah, very good. I saw. I think Amiga Bill was playing that there a while ago when it came out. It's excellent stuff. And I think he did use Blitz. That was kind of early days for the Scorpion engine. I think kind of a proving ground for the Scorpion engine, if you like. So yeah, there you go. That gives you an idea of what Blitz can do. But yeah, thanks very much for popping in, guys, and welcome along, everyone. If you don't know me, I'm Rob. I kind of do whatever I feel like in the week on my streams. I don't always even stream every week, but at the moment we've got a Blitz Basic game jam that's coming up. And if you're not aware of this, it's basically a competition. We've got 3 months to write a game in Blitz Basic, and I said this is a good idea to try and get people involved in the programming, and so to get people who might want to create a game to give them kind of the tools they need to do it. And so it's kind of a nice kind of raise awareness thing. So I'm running a load of tutorials at the moment, and that's what I'm doing. They'll be available on my Twitch and on YouTube and stuff like that. Oh, thank you Zuperdan. There's the Zuperdan is hosting this game jam, and we've got 20 something people signed up for it already. It doesn't have to be a fancy game once it's a game. And it doesn't have to be finished. You get more points if it's finished, but have a go. This is what it's about. And sure, you might learn something in the meantime. But yeah, all the details are on the jam there. I am going to be entering it as a team effort with the Scottish Amiga user guys, and this is the thing as well. Join the Discord. There are people there who have offered their services for making music, I think, and for making sound. So if you kind of think, oh yeah, I'd like to give the coding a go, but I can't do graphics or sound or whatever, team up. And it'd definitely be awesome to see all these all these games coming out. Here's one of the Scottish Amiga guys here. Andrew, yes. Yeah, well, I might do the coding, but I'm sure I've told you, someone else can be in charge of the game design and the graphics and stuff like that. So that's where you can step in and you can write the background story and all that. Oh, I have programmer art. I've got that. Placeholder graphics. Yeah, exactly. That's what you can do. But yeah, so there you go. But seeing as this is weekend, I'm having a beer as well. So cheers, guys. Cheers, everyone. Cheers, Raiders. Join me for a beer if you like. Now, So what we're doing here is we are opening an Intuition screen, and we're going to just like scribble all over it. So this is a cheers. An Amiga and beer on Friday. Yeah, there you go. It doesn't get much better than that, does it? You know, I'm looking forward to when we get a new Scottish Amiga user group meetup going, because we tend to have the usual, you know, sensible soccer tournament and a few games, and then we head to the pub. And it's yeah, they're fun. They're fun. But yeah, so what we've done is we've set up our bitmap. These and by the way, I'm all for questions and stuff in the chat for anyone who's just joined. Fire questions at me and discuss the stuff. And I'm not going to say I know all the answers, but I will try and answer and try and demonstrate it. So and I do see the One Life Left stuff, and I'm definitely gonna have to make it down for one of them at some point, because it's a nice setup in the cafe there. I think I've done two. This is my second stream here, and both streams I have learned several things. A surprising amount, to be honest. So I definitely don't know everything, don't know the answers. But okay, so we've set up a bitmap. We've set up quite a big bitmap. It's 1024 pixels wide. It's 200 pixels high, and it is given the ID of bitmap 0. And it's 5-bit planes deep. Now we've just drawn a line. We've drawn a dot, a line, and a circle on it. And now we're opening a screen with the name test. The view mode is 0. That just means a low res thing, and I was just demonstrating the help system on AmiBlitz. So you hold down shift and press help, and it opens up the page of the help file and gives you all the stuff you need to know. Blitz Basic manual is a bit it does a lot of magic numbers stuff. So so you kind of have to look up the manual and see what numbers are you put in. The operating system itself will give you better, it'll give you constants, and you can type an actual sort of more meaningful word in there. But we're going to go with this for the moment anyway, just to show you this is where you can look things up. So we're going with low res, which is 0, and that's also that hex number should just be there. But okay, so that's our view mode there. Pressing help without the shift gives you your parameters at the top of the screen there. But that's it, and we give it the name test, and then the detail pen and the block pen. Now they're actually they're the white and black pens in your basically they're not really used except for in Kickstart 1.3 or 1.x. So in Kickstart 2 they kind of became an automated thing, and you don't worry about them. I just put in 0 and 1. I think because they are kind of accepted values for Kickstart 1.3. But yeah, they're basically if you open a window or a screen on Kickstart 1.3, you'll see that the pens used for drawing the title bar actually change if you change those numbers. But it doesn't have an effect above Kickstart 1.3. It's kind of so it's just there for compatibility. But so that's once that screen command is executed, we should have a screen. And now I have a stop command there, which will pull up the debugger. But I'm going to change that to our little pause routine. So we've got a little pause function at the top there, and so what that'll do is that'll open our screen, then it'll pause, then show bitmap 0. Show bitmap, and you can see there it gets a bitmap number. That will basically tell the screen to display that particular bitmap. Okay, and then we'll pause again, and then we're going to go changing a palette value. So the RGB command changes the register 9 on the currently used screen. Now there was a discussion on the Discord earlier about this. So the concept of palettes. Okay, so in Amiga terms, you've got the raw hardware registers, which tell the beam as it's drawn on the screen what color each pixel has to be, and that's kind of that's low level hardware stuff. We're not going near them. The next level up from that is basically each screen or each slice that can be called in Blitz mode. I'll come to that later. But each screen, let's say, has a set of colors, and when the screen starts to be drawn, those colors are copied into the hardware registers. So if I pull down the screen like this, you can see we've got the workbench. I'm pointing at the screen here thinking you can see where my finger's pointing. We've got the workbench here has a palette. Okay. And then when we get down to these blank lines here, see even the sprite is cut off for the blank lines. In there, our palette is changing. And then the Blitz screen palette is in force. And during those 3 or 4 lines of the screen there, that's when the palette details are being copied into the hardware registers, among loads of other stuff as well. So the RGB command is changing the registers directly related to our intuition screen, not our physical screen, our intuition screen. So like our Blitz screen or our workbench screen, we're going to open a new one of these pull down screens, and we are changing the colors that it will use as it draws. Okay, so we're changing pen 9. And we use that for the circle. So basically this is just going to change the circle. So now these are our red, green and blue values, and you can see they're 15, 12, 3, which is maximum red, kind of high green and low blue. Yeah, you can do, you know, high resolution, low resolution, and we'll see that now in a minute because I'm going to open a low resolution screen. But yeah, it as well as changing the palette in there, you're changing, you know, you're changing the actual configuration of the chipset. So you can change it to, you know, you can change the pixel clock, you can change the, you know, all the properties of the screen there in those. And depending on how much you're changing, you might need an extra couple of lines. But yeah, that's it. You also get you get all your sprites reset as well, so you can have sprites down here and independent sprites up here. You do lots of cool stuff like that. And that's the Amiga. Cheers, Amiga. Oh, it is. It is definitely ripe for tricks, but it's used a surprising amount. Like what do you use? Like Image FX, for example, has a toolbar down at the bottom. A lot of games use that. Like if you look at Worms, where you select your weapons at the bottom of the screen, that's essentially a separate screen display, and it has its own palette, its own tricks that it does. Yeah, that's it. It's fantastic, and that's basically what's doing that. Is the copper is reloading all the registers that define the screen. That's the copper doing that in there at that point. And what all you're doing when you drag the screen down is you're telling the copper when to trigger. Yeah. Windows M, and M flicks between them. N always goes back to workbench. So M for Miggy and N for not Miggy. Yeah, there you go. Now, then the next thing that happens after the pause is oh really? Oh, I didn't know that. Wow, impressive stuff. Did you port it from Basic, or did you port the assembly, or rewrite the core of it for 65816? Because yeah, it would be 68,000 for the Mega Drive, but not for the SNES. That's impressive work. Because for those who don't know, Worms was written in Blitz Basic as well. So all the tricks you see in Worms, it's all Blitz Basic stuff. But yeah, so once we've changed the color of the circle, the next bit of code is loading some graphics, an actual graphics file, and this is where things start to get fun, So I am going to make sure that I have that file there. Yeah, I'd imagine it doesn't really translate that well, but cool. Worms, all Worms Amiga versions. So Worms Director's Cut was Blitz Basic as well, but once they went onto the other platforms, it was probably something else, probably C. You know, well, once it went to 2, like Worms 2, I mean. I'm just going to see if that file is still there that I wanted. Smiley. What the hell is this song? It's on random shuffle on the mod archive, so what the fuck is going on there? Yeah, cool. Okay, we're on tutorial 6, weren't we? Smiley.if. Okay, it's in graphics. Okay, so now this is a thing I have to cover as well. So for now, what I'm going to do is I'm going to end the program there. Okay, so we're going to deal with loading other stuff another time, or well, in a few minutes. But for now, okay, this is all we're going to do, and we're going to pause, and then the program will end. So there's our screen open. Okay, now we have opened it wider than the thing is. Now we click, and we get our shapes drawn. And we click again, changes the color of our circle. Oh, now this is oh, funky, because yeah, we did do a funny screen layout. I don't know why we did that, but I'm going to change that because that's hard to do. So we actually opened the screen a certain chunk away across the screen. No, that's not what I wanted to do. We're going to move the screen back to 0, 0, which is the normal starting position for a screen. I don't know why it was set to 100 in this demo. And we're going to open, we're just going to open it 320 by 200, just to make things easy. Now, there we go. That looks a lot better. So you can see there, we can pull that down, and even though it's a low-res screen, now the old this is on WinUAE, by the way. WinUAE is struggling to redraw the window as I do that, but yeah, you can see there's 2 different resolutions on the same screen. Now, yeah, so we get our things drawn, and we click again, changes the color, ends the program. So, are we happy with this stuff so far? And we can see what was happening there. But do ask questions there if anything doesn't make sense. And what we're going to do now is we're going to load an actual external graphic file. Now, let's see. That's in. This is going to eat my chip RAM. Oh, this doesn't go well on the low color screens. What are we? Oh, there it is. Articles. Good Lord. Yeah. This tutorial 6. So, smiley.iff. It's not even going to... Okay, so that's what a graphic file looks like. Okay? So we're going to load that in as a graphics file, and then we're going to put it on our bitmap. Yeah, it's crazy stuff, isn't it? Yeah. Okay. So what we're doing here is, so after we've recolored our circle, we're going to load a shape. Now a shape is a graphical object in Blitz terms. Okay, they can be used for sprites, they can be used for blitting, and what blitting is doing is basically stamping that shape onto the bitmap. So blitting is kind of it's what your blitter does, basically. But yeah, it takes the shape and it will copy all the shape data into a particular position in memory. Usually on a bitmap, hopefully on a bitmap. You don't want it to blit onto your code or, you know, onto the operating system. It's going to ruin your night. But yeah, so blitting is kind of copying that information onto a bitmap in the right location or in the location you want. And so that's what we're going to do. But we're going to load that smiley file. It's not in shared, it's in the current directory. So we'll change that to smiley. And so load shape, again, we need to give it an ID. So we're giving it the ID 0. And just give it a file name. And there's an optional extra parameter on the end. If we look at the syntax here, optional extra parameter is a palette number. Now, this is a next level away from palette, the palette of the screen that I was talking about. This is an independent object and doesn't have any meaning by itself. Okay, I will get onto that after I finish talking about palettes. Auto Retro, thanks for the follow. Thank you very much. Yeah, so basically you've got a palette object in Blitz terms, and that's just a list of colors. So it doesn't have any kind of meaning by itself. It's just a list of numbers, but it's a list of colors that can potentially be applied somewhere, not actually doing anything at the moment. So when you load this shape, there's an optional parameter to store the colors from that shape in a palette object. So basically an IFF file will have usually has, like, if you save a file from Deluxe Paint or Personal Paint, like an image file, it will have hey well, nice to meet you. And welcome along. Well, yeah, so basically if you save a graphics file from Deluxe Paint or Personal Paint, it will have the bitmap and it will have a palette, and that palette describes all the colors that are set up in that for that file to look properly, to look the way you want it. So when you load it, you can store those numbers. You can ignore the palette if you want, or you can store it in a palette object, which I've numbered 1 here. And now the next command is show palette 1, and that will change the screen colors to whatever colors are in palette 1. So it copies all the colors from palette 1 into the screen's color registers, not the actual physical hardware registers, but the screen's color setup. And that means the next time this particular screen is drawn, it will use those colors. And now, what we do is first we load the shape, we load the palette, then we show the palette, and that turns on those colors for the screen, copies them to the screen, and now we do this loop. And what we're doing here is we're picking random numbers. So here's our random function that we were talking about the first week, or the first stream during the week. So RND, and that'll pick a number that will return a number between 0 and the number in the brackets -1. So if that number there is 320, it will return a number between 0 and 319. Now what we're actually doing here, so if we ignore the rest of that line, that will give us a number between 1 and 319. Okay? But what we're doing here is we're subtracting the width of the shape. And so shape width 0 gives you the width of shape 0 width. So we're after loading this graphical file because we don't want to blit outside the bitmap. Blitting outside the bitmap is bad news, and that will ruin your day. That is what I was saying earlier. So basically, when you blit a shape, by default, it's got a handle, and that's kind of like your mouse pointer. 0 to 319. Oh, sorry, did I say 1? It's 0 to 319. Yes, they do. Basically, shape width and shape height just return the values from the shape structure. So when you load a shape, it populates the Blitz object structure, and you can access that with the shape width and shape height functions. So they're pretty simple things. But basically when you load a shape, that by default the top left pixel is the handle, and it yes, it's the width of the bitmap. That's right. And the height of the bitmap. But yeah, so basically when you say, let's say you want to blit the coordinates 0, 0, it will put the 0, 0 of the shape at 0, 0 of your bitmap, and any extra pixels beyond that 0, 0, like the rest of the shape, are at 1, 0, 2, 0, 3, 0, and then at 1, 1, 2, 1, 3, 1 down. All so basically fills down and left. Now you can move that handle, and then I'll come to that some other time. But it means that if you blit a shape at 319 pixels across, the rest of the shape will be at 320, 321, 322, 323 pixels. And that's not your bitmap. That is, that could be your DOS library. That could be your code. That could be, other parts of the screen memory. But yeah, blitting across that stuff is just, it could be no man's land and might not make a difference. It could be, and something that, corrupts your files. It's, does it do a wraparound thing or something like that? But yeah, you don't want to blit outside the bitmap. The Blitz debugger will, it's a nasty one, and it is easy to fall into that trap. The Blitz debugger will catch it for you in real time and tell you, you can't blit outside the bitmap coordinates or bitmap out of bounds or something like that. But yeah, you really don't want to blit outside the bitmap. A clip blit is slow. Basically, it kind of does it does 2 blits basically, and to try and fit it within the area it's given. It's a lot easier just to make sure that it never gets into that situation in the first place by not allowing values that will possibly allow that. Yeah, so that's kind of that's the gist of it. So what I'm doing here is I'm taking the screen width, and I'm taking away the width of the shape. So that means the highest number that it can possibly think of will be at the far right with enough space, enough pixels left to blit the shape cleanly. So it'll never go over the right hand edge of the shape of the screen, of the bitmap, sorry. And the same for here. And this is, so I'm just storing them in 2 variables, X position and Y position. And then we're just going to blit. And that is, we blit our shape 0, X position and Y position. That's it. And that just blits your shape there. Don't worry about the excess on off. That's to do with when you've got mismatched number of bit planes. Don't worry about that now. What was the other question that was just a little while ago in the chat that I said I'd get to? Oh yes, so Zuperdan said, what is it with shapes that makes it faster if it does, or is it a memory thing? Okay, so blitting takes time. It does take a lot of time. There's no real getting away from that. The blitter can do a certain amount of work, and while it is pretty cool, it is an impressive bit of silicon. It's not a miracle worker, and it does take time. So there are lots of things that affect it. First off, if you're doing special blitz in Blitz Basic, like I'll deal with different types of blit in a little while, but some of them involve multiple blits, like clip blit, which does sort of a second blit over the first, so it does a sort of a second blit that copies out the section of the first blit that fits, and so you've got a double blit basically. Buffer and Q blits both take a little bit longer. Oh, sorry, no, Q blit doesn't. Buffer blit does. Yeah. And stencil blitz also take a longer time. But yeah, basically blitting copies the data bit plane by bit plane. So if you've got more colors on the screen, if you've got more bit planes involved, it will take longer to blit. Blitting also works in multiples of 16 pixels. Yeah, it did exactly where I was going. Yeah, in multiples of 16 pixels. So if you blit on a 16 by 16 border on the bitmap and your shape is up to 16 pixels wide, it basically takes the same length of time to do that. But if your shape is like hi Paula. Whoop whoop. But if you're if your shape is like, let's say 17 pixels wide, it has to sort of do, it sort of rolls over into the next square of the shape of the bitmap, so you can't fit it into the neat little 16 by 16 rows, and if it's not on the border of 16 pixels. Like, let's say you're blitting 16 pixels wide and it is on pixel 8. Your shape will take up the space from, let's say, pixel 8 to pixel 23. But that straddles the border between two sort of blocks of 16. So you have to blit all the way to pixel 32 for that to work. And that makes things a bit slower as well. So there's a special form of the blit command, which Fryer mentioned there, which is block. And that does blitting much faster. But it only deals with shapes that are 16 pixels wide, and it only deals in borders of 60, 60, 60. Yes. Yeah, it does. Yeah, absolutely. Yes, because it doesn't use the cookie. Yeah, so it is quite a... It is a significant difference, but block is very, very useful in certain cases. Like if you're doing a tile-based game, you know, or if you're doing like a scroll where you're wrapping the screen around itself, you know, there are views of different ways of doing it. But yeah, doing block, it saves you a lot of time. Yeah, absolutely. It's because if you use the cookie, it's a special kind of blit. It does take a little bit longer to do that, and you know, it's just, yeah, it's basically taking a shortcut in the blitting process. But yeah, it does do. I think so. I'm not going to say yes for definite because I can never remember which blitter channels it uses. Okay. So just to explain a little bit there, the blitter works with different channels, and it can combine data, and it can process data from I think up to 3 different sources. See, the details are a little bit vague, and that's why I don't want to commit to that. But basically, you can say that like a source A, source A and destination D, it's literally just copying the data from one to the other, and that's why you can't use transparency, because what you want to do is you want to combine A and B and let B shine through to A, if you like. So you only copy the pixels in A that aren't 0, and then B is left in the background, and then you copy that to D. I think so, but I don't know for sure. It's a while since I've dealt with the blitter in that kind of level, and when I say a while, it's like 20 years. But yeah, it is something like that. But yeah, so for the moment, we are just going to blit the shape there, because blitting, while plain blitting, you know, if you can align things and you deal in 16 by 16 squares, beautiful, and you get so much more blitter time. Yeah, that's it. The block command is very, very handy for that. But ultimately, most games you're going to want a finer resolution than multiples of 16, and you're going to want the shape of your shape to take account of it. And there you go. Nivrig will be more familiar with that stuff after his Turbo Tomato shenanigans. But yeah, dealing with tiles, and like I say, I use that for doing you know, if you're on if you're doing a large scroll, a map scroll, using block to draw in the tiles before you get to the edge of the screen and stuff like that is good. It's really good. And for, you know, continuous for 4 and 8 way scrolling, like, you know, so you can copy bits of the bitmap to the other side. Yeah, it's nice. Is it all 4? Yeah, fair enough. Yeah, well, there you go. So that's kind of a brief tour of the blitter. So basically that's what we're going to do. We're just going to we've got a loop of 5 here. Oh, excuse me. And we're just going to basically blit 5 of these shapes on our bitmap. And we're going to pause in between each time. And so again, we're seeing here that we're using the same code, which is completely independent code up at the top. So let's give this a run and see if it works. Excuse me. Word of warning. The load shape command is unforgiving, and most of the loading and saving commands are unforgiving in Blitz. It's a little bit poor that way. It's a weak aspect of it. If the file doesn't exist, or if it's not a valid graphics file, it's a hard crash. Okay, so it doesn't do any checking, and just bear that in mind. Now the debugger will catch it, so have your debugger on when you're doing that. But just bear that in mind, that you'll get badness. Oh, and what was the other question? Sorry. Yeah, the shape concept, I'm not really sure if it is any better for dealing with Blitter, because it's just basically a set of bitplane pointers. It's essentially a bitmap, which is kind of what Blitter deals with either way, you know. So if you load it in, it loads it in. It's a bitmap in memory, but just with some extra parameters that Blitz applies to it, like the cookie pointer, like your handle coordinates, and the actual size rather than the Blitz size. You know, there are a couple of other properties that a shape has, but it's not a huge deal. It's essentially a fancy bitmap with a couple of extra values added to it. That's all. So that's all the shape structure is. If you go and look at the shape structure, it is. Can we look at it here? Oh no, we don't have it. We don't have it declared, so we won't be able to. But you can look it up in the manual. It's just, you know, a couple of parameters and bitplane pointers, and that's it. So let's give this a go. See if it runs. We will turn on our debugger. It is a minor bug here that it doesn't show that it's on when you load up first. It's actually switched on, but the check mark isn't there. So when you click it once, it turns it off. Now, okay. Now click. We apply our bitmap. Now notice that the bitmap has drawn over the title bar. It's still there, and you can still click the gadget. It's just been drawn over. Now we change color. The next step is to load the shape and apply the palette. So there's our actual palette. Blitting, blit, blit, blit. Now we're drawing graphics. We're drawing actual, you know, not just like pixels and lines. This is a file that was a PNG or a GIF or something, and I converted it to an IFF and loaded it in. Ship it exactly, yeah. Sorted. This is my entry to the game jam. Time for beer. So there you go. Any questions on that? Anything else we want to see, or you want to see me try or do there? Oh yes, we have to be nice to Nivrig. He's one of the judges. So yeah, I definitely won't be doing any development of the of any game on this stream, on these streams. No siree. But I've poured my heart and soul into this game, I'll have you know. Right. But yeah, so there we go. Now we're at a point where we can load in a shape. We can put it wherever we want on the screen, and it's all system friendly as well. You know, what I will do is I'm going to change this until joyb0 equals 2, which is the right hand mouse button. Oh no, and 0. So we have to click the right mouse button. That will allow us to show you what's going on. So we can pull the screen down and move it around a bit. Well, the resolution switch there is killing. That's WinUAE that's actually messing up there. But you can see we still have our screen bar. We still have the button, our gadget for flipping screens. But we have to click the right hand button to go to the next step. So yeah, there you go. So you can see it's a fully, it's a full Intuition screen, and we're just drawing to a bitmap, and that bitmap is displayed by the screen. Yeah, it is, and it's kind of if you're on the real hardware, it does that instantly and seamlessly. It doesn't do it there now. So yes, show moving bitmaps about, and this is the simplest type of scrolling. Is if you've got a bitmap that's big enough to hold all of your, where are my hands? If you have a bitmap that's big enough to hold all your graphics that you want to see, you can just take your window, your screen, and move the screen around and show different parts of that bitmap, or kind of move the bitmap around depending on your perspective, whether you're inside or outside the monitor. But yeah, so yeah, I will do that, and I think that is in this next tutorial. Let me see. Tutorial 6 example finished. What's finished? Oh yeah, no, that's our application. Okay, yeah. That's, there you go. Nice font. Yeah, let me out. Nice font sensitive GUI there and everything in Blitz. Yeah, that's fine. Pay no attention to the pointers there. So let's move on to tutorial 7. Let's see what example 1 is. Oh yeah, well let's do this one. So this is basically the same program, but we've got queued. We're using a queued blit. So I'll get onto scrolling now in a minute. This will show you how to actually sort of deal with moving the actual graphics and changing them. Yeah, I know it made more sense when you're not doing it this way, you know, because these are all tied into like WordWorth files, and yeah, so when I was sending them into the magazine, this is how they went in. But I tell you what, I'm just going to go run and get a quick beer. Because this one's empty. Oh, back in a sec. Ha. But yes, it is. I know you're only joking, but it's kind of like you know, I didn't really think this through when I started saying, oh, I'll just go through the tutorials from Amiga Future. Yeah. Anyways, so what we're doing here is, this is almost the same program. You see, we're opening the same screen. We're loading our shape. We're loading our shape first. Excuse me, and you can see you can do that, and usually that's how you would do a game, is you load it before you open your screen, or you know, before you're in the middle of running the game. You kind of load what you need first, or at least have it in between. Okay, good night, Nivrig. Thanks for popping in. And what's good? Oh yeah. Well yeah. Hope you have a nice day tomorrow, whatever you're doing. Okay, so the quickest way of doing animated graphics or moving graphics, basically when you blit, you're literally copying that image onto your bitmap, and then it's there forever, like it's part of the bitmap. The data is in your bitmap. The data are in your bitmap. So so you've got So you've got a couple of options. You can manually erase that image and redraw it somewhere else if you want to move it, and that's kind of what a queue blit does. So so what you do is you set up a queue object. Now, yeah, here we go. So our queue is 0, and a maximum number of objects that we need to remember. And what a queue does is it stores up where a particular object was blitted and what the object was, and it unblits it when you choose to unqueue it. So you can fill up the queue. So we've got a limit of 2, but you can set that to 20 or 50, and all it does is it keeps a record of everything you blit onto that queue using that queue number. And then when you use the unqueue command, it erases them all. and it erases them in. It just blanks them all out off the bitmap and leaves a hole in the bitmap essentially. Like so, it fills them with zeros. You can use you can use this command to fill in the bitmap with other data. That I'll get to that later. But basically, this erases the shapes, any shapes that were blitted since the last unqueue, and then leaves the bitmap free to be blitted on again. So, yes, exactly. So this is handy for when you don't really need any information on your bitmap. So if your bitmap is just like empty background color, you can cube blit, and then you can you literally just erase the shape, and then you can redraw it somewhere else. So you can create the effect of movement there, and key to that is the VWait command. Okay, this is important because, and the placement is important as well, as we found. So the VWait command waits for the vertical blank that we were talking about. Okay, and so it waits for the screen to be drawn, and then pauses the program until the screen is finished redrawing, and then is the beam is coming back up. Yes, it does. Yeah. These are, sorry, I should have said that. These blitting commands are kind of universal. They don't care about the mode they're in. They are for using the blitter to copy to bitmaps. So bitmaps as well are universal. It's kind of bitmaps are they're an Amiga thing rather than a Blitz or OS thing. So so they're kind of universal concept. And most, like a lot of the things are. I'll say. I will mention things when there's a difference between specific modes like that and specific contexts. But yeah, so VWait, it waits till the screen has been drawn, and then then your bitmap's at the top. Then the beam, as you got the little blank, then is the time to unblit all the things while the screen's blank, and then you reblit your new shapes. Okay. Hey, Night Shift, welcome along. Welcome along. Cheers. Happy Friday. So we are. You're just joining us. We are just talking about blitting shapes and moving shapes around on a bitmap. Okay. So in other languages like Amos and stuff like that, and even in Amiga OS terms, this would be called a bob. A blitter object. So what we're doing here is we are going to basically count to 100, and we're going to blit at coordinates of the loop. So 0, 0, then 1, 1, then 2, 2. So what should happen is we should get our shape appearing at the top left and moving slowly downwards to 100 by 100, and every once a frame. So that should take 2 seconds. Okay, and it should erase as it goes. Okay, so we give it a go. See if it works. But basically, the program is pretty much the same, other than we loaded up the shape first. Was there another question there? No, buffered blitz and cube blitz. Cube blit is much faster than buffer blit. Yes. I will get onto buffer blit later, but essentially what buffer blit does is, instead of erasing the shape when you unqueue it, when you unbuffer it, it replaces the graphics that were there before. So it does a nice neat repairing the bitmap as it was, as if you never touched it, as if you never blitted, and that's cool. But that exactly, yes. But to keep the background, what it does is first is it blits the shape, it blits the outline of the shape and the information that's on the bitmap. It blits that to the buffer, and then it blits your shape in. And then when you unbuffer it, it blits the buffer back onto the bitmap. So you've got extra blitting steps involved there. It makes it significantly slower. So it's a case of whether it's worth it or not, and there are very good reasons to use it and very good reasons to avoid it. So But yeah, exactly. It basically halves the number of moving objects you can have on screen. You know, but it is very convenient. It is really, really nice. But yeah, anyway, let's give this a go. See if it works. Okay, so we've got our screen open first, and we click, and we get our guy moving down the way there. Now, you did notice there's tearing and stuff there. That is basically because we don't have a double buffered bitmap or double buffer display. So what's happening is the beam is sort of reaching the point where the shape is being drawn, and that's why it wasn't happening further down the screen. So we'll do that again and we'll look at it. And you can see around about here is kind of the line where exactly, yeah. So we've only got the one bitmap involved here, and that's all we're showing. So you can see the blitter kind of in action. It takes about here. That's how long it takes for the erasing process to happen. And then you're blitting, and the beam has already got down to here. So when you blit, you're only getting some of the bit planes, and that's why the colors look a bit funny. Now you can solve that by speeding up your blitting, by using smaller shapes, by fewer colors. But really what you want to do is you want to double buffer. Hey! Yeah. So yeah, I will cover double buffering, I think, in the next tutorial. Well, like in this stream, I can do that. So that's kind of but this is kind of like the basic mechanic of moving items on the screen, moving objects on the screen. So that yes, exactly. And if you're only drawing something once, and you're leaving it on screen for a long time, you don't really notice the flicker because it just sort of flicks and it's on. So I'll show you. For example, let's say we'll do it. So what's going to happen here is we're going to delay for 1/5 of a second every time that moves. So this will make it a lot slower to move. Let's have a look at what it looks like. So you can see, yeah, you can see it flickers, but it's definitely looking a lot better. You know, so if you're on, and that is like in Amiga terms, that's a very big blit. Okay, that's one single big colossal blit. A lot of, you know, most games wouldn't have graphics that size, but you can see there when you get to the end, it's practically perfect because it's kind of blitting further down than where the beam is reached. But yeah, so there you go. That's that is the basics of moving a blitter object around, you know, blitting and erasing. A brief overview of what double buffering means is you've got two bitmaps, so you only draw to a bitmap that isn't being shown, and therefore you've always got a fully intact bitmap on screen. So you're not erasing, you're not blitting, you're not doing anything with the bitmap that is actually being shown. And because changing the bitmap that the screen is showing is literally just changing a pointer, it's very quick. It's basically instant. So you can do that very easily within the vertical blank. And so yeah, so that's moving the shape around. So you can see so, but yeah, especially if the shape is small and your draw frequency is low, you can get away with without a double buffer sometimes. Yeah, it depends, and sometimes you don't know until you try it, you know. But yeah, so there you go. Does that make sense to everyone? Any questions? While I take a drink. Yeah, and the thing is as well, I'm running a fast WinUE setup, but I'm also running the debugger, which makes things very slow. So if I switch off the debugger, you might see less flicker. No, you won't, but sometimes you know, it depends on what you're doing. That, like I'm saying, that is a very big blit. It's probably too big because it's erasing it and it's redrawing it, and that's quite a big shape. Yeah. We can do 4-bit planes. I'm not sure if that'll speed things up because our shape file is still going to be 5. But yes, reducing the number of bit planes, using smaller shapes. The colors might go funky, but it also might still try to blit the 5th bit plane. I'm not sure. Look, we'll try it. If we crash, we crash. Fine. Oh, 4. My 4 key is being a bit iffy. Is this the same tune again? Well, the colours went funky. The drawing was not ideal. Actually, I've just had a thought. Usually you do the V-weight at the immediately before you do any kind of drawing. Yeah. Well, see, this isn't even drawing the entire screen, redrawing the entire screen. It's just redrawing one object, but it's a big object. But yeah, you wouldn't normally redraw the screen every frame. I'm just like a little experiment here. Yeah, no, it hasn't made a difference. But sometimes the when you're dealing with intuition screens, having the V-weight after you've drawn helps. Yeah, 44 bit planes. I'm not even going to attempt to calculate that. Yeah, that is many bit planes. Let me think. 4 million. Yeah, the trillions of bit planes. Definitely more than you need for the game jam. But yeah, so yeah, basically, yeah, you can get away with it if you're very careful with your bit plane timing or with your blit timing, and yeah, it's but usually, almost always, you're going to want a double buffer. It's just this is just showing you the mechanism of actually moving an object around on screen, and so that's kind of that's the object. That's the object of this. That's the object of this basic example. So we'll move on to the next one. Example 2. Oh, this is buffered blitz. Okay, so here we can see we're buffering the blitz. So this is kind of the same program. Yeah, because that's crazy talk. That's next gen shit. Yeah, so that is oh, if you want to use more than 8-bit planes, you need to use Ami Blitz 3, by the way, because Blitz 2 does not support more than 8-bit planes in most of its operations. But Ami Blitz 3 does, and you can open a screen in 16 or 24-bit. Oh yeah. But yeah, here's the we're going to give this a go. This is buffered blitz. Okay, so now it works almost the same way as queued blitz, right? As in, you draw into a you have a, instead of a queue, you have a buffer, and you draw referencing that buffer, and then you unbuffer, and that erases everything. But this one restores the background in between. So the difference is, when you're declaring the buffer, you don't choose how many steps to remember or how many blits to remember. You have to reserve an amount of memory. So I've reserved 32k here. It doesn't need anywhere near that much, but you could calculate it, I suppose, by by adding up all the blits you're potentially going to do, the maximum size of all those blits. But yeah, I just throw 32k at it and I'm done with it. But basically, that reserves a chunk of memory, and all the backgrounds that you blit on get copied over into this space, and then they're there for being restored later on. So I got aha, yeah, that's a nice approach. And yeah, changing your palette on the way down as well. That's pretty cool. Yeah, I saw that actually. Yeah, good stuff. So, so what we're doing is we're just this loop here is just drawing a load of random lines on the screen, just so that we have a background. Because in the last one we had the bitmap was empty. It was just color 0, so it didn't really matter at all. So so now our bitmap is going to be filled with lines in random colors. And again, you can see that interestingly, it's going to draw some like a certain number of those lines are going to be blank. So how we change that is, so this is picking a number between 0 and 31, of course, because we've got 32 colors. So I'm going to say we pick a number between 0 and 31, and we add 1 to it. So that'll pick a number between 1 and 32. 1 and 31. So that will pick a number between 0 and 30. Okay, so now we get random colors on the screen. And what we'll do is, or what this will do is, this will do the same thing. It will just draw the shape moving, but this time we have a background and the buffer will, so there's we have all our lines, and now we're blitting. Again, we're erasing, and you can see that it's erasing, but you can at least see that it ended, when it does stay drawn, that it is over the background, and that the background is still intact where it was. So that is that's the difference, and that's just a demonstration of buffered blitz. They are slower, and so you probably get even more tearing and jittering there. Yeah, it's just as bad, I suppose. But it does take longer to do that operation because there's an extra blit involved. Sound good? Okay. So let me see. I think the next one is going to do a queued blit with a restore. Let me see. If it's not, I'm going to show you that anyway. No, it's set up to a kind of a funky machine, and it is a lot faster, but the blitting isn't. It is a fair point though. I'm going to set it to chipset cycle accurate and just see how it runs. Well, if you want to be able to restore the background, so if you want the shape to be able to move without destroying the background, that is a reason to use buffered blitz. And if you don't need the speed, then that makes things convenient. QBlitz can restore the background as well, but only if nothing else was blitted in the meantime. So this is where it gets complicated. Is if you've got overlapping blitz, and if you've got multiple blitz like that might not necessarily be always overlapping, like two different players. It's it depends on how, there are a few things. Some things won't be redrawn every frame, let's say, and some things will. And if that's the case, then QBlitz won't really work because it'll raise things back to the original setting or the original content, and then your the things that don't get redrawn every frame will disappear. So that's a reason to use buffered blitz. It's also I also use buffered blitz as a kind of a shortcut in Nivrig gone, but I use a buffered blitz for doing the menus in Dodgy Rocks. So you just do one dirty big great blit in the middle of the screen, and then you can unbuffer that in one go. It doesn't matter that it takes too long, because you're only doing it once and it's drawing the menu background, and then you unbuffer it and instantly you've got your game screen back. It might take more than a frame, but who cares? It's a one-off thing. It's not kind of like part of the game as such. So there are a couple of things. Let me just see if I can do this. Chipset cycle exact. So we'll do that in A500 speed now. Oh, I've made a mistake. Now it's taking time to compile. slow. You see, you see there. So it's still moving, like, but it's the problem is not the blitting being too quick, if you like. It's just that the blitting simply does not take, you know, it's blitting while you're looking at it, because the screen still has to be updated at the same rate, regardless of what speed your emulation's running at. The screen is still being drawn at 50 frames a second, so it's still, you know, you've still got kind of the same kind of timing in that way. QBlit for the scroll routine. Well, if you can get away with it, you would not. If you're just drawing backgrounds and stuff, you would probably try to avoid using QBlit, because even that takes longer than a stock blit, you know, because it's still storing a few details. It's almost the same speed, but it's just fast as possible again. Okay, there we go. Yeah, so yeah, if you can use block, then that's the best for doing a scroll routine, because you know, if you design a tile map that isn't 16 or multiples of 16, that's yeah. You need your head examined. Yes, sorry, yes. Yeah, block rather than qubit, yeah. Okay, well, what I'll do is I'll show you, I'll see what we have in the next one, yes. Example 3. Okay, now we're getting on to double buffering. I don't want to do double buffering just yet. What I'm going to do is I'm going to open the previous one again. Or which one will I use? Yeah. I'll show you the alternative way of doing that. Okay, so this is buffered blitz, but what we're going to do is we're going to change it to a QBlit. And I'm going to show you an alternative way of we're just going to set that Q to 2. So now absolutely get cracking. Yeah, so basically I've changed this is the one with the background. So instead of doing a buffered blit, we're doing a QBlit. Oh, I shouldn't have saved that. But anyways, let's have a look at what that looks like. Oh, yeah, see, now that would have been a hard crash if the debugger wasn't running. Can't open IFF because it's not on that drive. Now, so we've got a background, and we can see you can see what's happened there is, and you can see because it's on multiples of 16, that shows you what the blitter has to do. See, even though the shape only goes as far as here, it's just about spilling over into the next region, and so you need to blit all the way over to here. So, you know, there's an interesting yeah, it is, yeah, there you go, there's an interesting look at that. So that's what a queued blit does. You see? So what I'm going to do is I'm going to show you how to use a QBlit to restore the background. So let's say we've got a bitmap 0, 320, 200. So we need another bitmap, and this, so to use this method takes a lot more chip RAM. But if you're dealing with small bitmaps like this, then that's probably fine. So now we've got another bitmap 1. Okay. And now we've drawn all our lines all over it. Now, this is a nice little command. Does exactly what it says on the tin. Source bitmap and destination bitmap. So we're going to we've drawn all our lines on bitmap 0. Oh yeah, so no, because we've got 2 bitmaps involved, we use bitmap 0, and then all the lines will get drawn to bitmap 0, and then copy bitmap 0, 1. So now we've got 2 identical bitmaps, 0 and 1. It's slow. It's using the blitter, I think. It's slow. It's not something you want to do every frame or anything like that. Use it at the start of a level. You know, that's the way I would do it. You don't want to do this for a tile scrolling map, because that's not going to work. Or well, yeah, copying an entire bitmap is not. Yeah, it is. It's basically, it's not. You're literally copying all that data. It's not something you want to do quickly. Yeah, exactly. That's exactly where you want to do it. Is doing your double buffering, or this isn't double buffering strictly, or it's not double buffering at all. But this is a very good use case for that. So you've drawn your level. Let's say you've drawn your background. Copy the bitmap, and then you're showing bitmap 0. But if you see here, unQ has an optional extra parameter of a bitmap. And we give that bitmap 1 as a parameter. And what that will do is, instead of wiping the bitmap where the shape used to be and just blanking it out, this will actually take a chunk of the other bitmap from that location and copy it into the main bitmap. And let's see what that looks like. So there's our background. And we can see that is exactly the same as the queued bitmap. But it's faster because it's not taking a copy of the background first. So you don't have, there's an entire blit that you're not doing there. And so that is kind of, if you have all your moving, oh yeah, copy bitmap. Yeah, you don't want to do that. If you have all your moving items being redrawn every frame, this is a very good way of getting some extra speed. You don't need to use buffer blitz if you're redrawing all your moving objects at the same time, or you create an algorithm that deals with overlapping moving objects. So there are other ways of doing it, but basically, if you have to know that anything that you erase is going to be redrawn, and if you know that, then this is a very good way of doing it. And I use that for most stuff, I think. So I definitely use it for dodgy rocks. I use it for kind of pretty much most of my things. So it is. So to recap, it is quicker than doing a buffered blit by a significant chunk, because it's instead of essentially using the blitter to fill it with zeros, it's just filling it with other bitmap data from your backup bitmap, if you like. But yeah, this is also the reason why Dodgy Rocks needs 1 megabyte of chip RAM, because I'm doing this scrolling loop on a double-sized bitmap. I'm double buffering, so I need 2 of them, and I've got this reserve bitmap, so I need 3 of these bitmaps. Yeah, I wouldn't use copy bitmap in the main loop because it's just too slow. You'd use this at the start, but once you've done the copy bitmap, you only need to do it once. What unQ does is it copies just the section of bitmap that the shape was occupying. So it's essentially the same as a blit. It doesn't take that much time. So you can see, like, think of this loop as my main game loop. I haven't done any copying of bitmaps in there. The copy bitmap is, I haven't even got the screen open when I copy the bitmap. So there you go. It is like a pseudo buffered blit, but if you have objects that maybe don't move every frame and you can't afford to redraw them every frame, yes. And a little blit here, yeah. So if you can't afford to redraw all of your objects, or you don't know if your object's going to be overlapping and stuff, and you can't work out whether they're overlapping or not, it's a buffered blit is the kind of like the gold standard, if you like, but it does take longer, because a buffered blit will restore whatever was there, regardless of whether it was on the original bitmap or if it was put there later by another routine. That's kind of, yeah, that's your gold standard, okay? But queued blitz are faster, and significantly so. So that is a very nice way of doing things, and it's kind of the way to go if you have a background graphics and you're not doing dual playfield or something like that. Okay, so now Yeah, it's quite nice, and it's literally just you just need a basically it's you know what I would call a clean bitmap, and what I think what everyone calls a clean bitmap. But yeah, if you give it a try, and it saves you a significant amount of blitting. But yeah, so you need to have a clean bitmap, a virgin bitmap, and that's kind of what you would need to refer it back to. Okay, so now example 3. Here we go with our double buffering. So now we're going to do a buffered blit, and we're going to do double buffering. We can also do a qublit here either, and have a third bitmap as our clean bitmap. But yeah, it's fine. So look at what we're doing here. We're doing we're loading our shape. It all looks the same, and we're setting up 2 buffers now, because we don't want to erase everything at the same time. We only want to erase what we're not looking at, if that makes sense. So we've got buffers labeled 0 and 1. We've got bitmaps that are 0 and 1. We've got our lines. We're copying the bitmap from one to the other, so we've got 2 identical bitmaps. And we're doing it the back where like I did use bitmap 0 so that we were drawing to bitmap 0 and copying it to number 1. This I didn't bother for this example. I just took bitmap 1 and copied it to 0. So when you're doing any kind of graphics work, it always works on the currently used bitmap, and that is either the most recently created bitmap or whatever the last use bitmap statement used. Okay. So yeah, so basically so that's why these random lines were drawn to bitmap 1 instead of bitmap 0. So now we open our screen, we show our palettes, all the usual stuff. We pause here. Now I have a variable here called current bitmap, and then what we do is we show bitmap makes the screen look at current bitmap. So show bitmap, that's going to be either 0 or 1, and it's 0 here. So show bitmap puts the screen pointing at bitmap 0. Now we wait till the top of the frame, then we swap over to current bitmap. We swap that to basically the other bitmap. So when show bitmap is showing bitmap 0, we wait until we get our vertical blank, and then we can draw on the other bitmap, bitmap 1. Okay, so actually that line could even go there. It doesn't really make a difference. But when you're doing intuition screens, you need to have the V wait after show bitmap. When you're doing slices or display library cop lists, you need to do it before you switch bitmaps. And the reason for that is just how the interrupts are handled and how intuition deals with the screens, because you cannot guarantee the timing otherwise. Alt cursor up and down. That's genius. Excellent. That is awesome, because it is like almost muscle memory now for me to do the delete line, undelete line thing. Oh, that's made my night. Cheers. Oh my god, I'm going to be using that the whole time. Look at that, look at that. Amazing. Thank you. That's great stuff. Absolutely. Yeah. There's a lot of stuff like that. And there you go. Like, there's so much stuff in Amiga Blitz 3 that's so much nicer. And it's still, I'm still learning more. And you'll have noticed, how long are we on now? We're at like 3.5 hours. And no Amiga Blitz 3 crash. What the hell? I think I was just low on chip RAM, and I was kind of hammering the chip RAM, I think, on the last stream, and that's why it crashed. But yeah, seems to be working fine now. Watch it crash right now. As soon as I try to do anything. Yeah, because that's my muscle memory is Amiga delete, Amiga undelete for moving lines around. This is a game changer. Hey. Okay, right, so look at what we're doing here. This is our game loop again. You know, call it our game loop. We're just moving it, our object around. Yes. Yeah, indeed. I have been in situations though where I've been on a real hardware, you know, and I would hold down. I like a nice fast keyboard repeat rate, and I'd hold down right Amiga D, and be deleting like loads, a big chunk, and then I'd take my finger off, and it keeps going because it hasn't been deleting as quickly as the keyboard's been repeating, and I'm like, no, stop it! I end up deleting half my bloody code. Yeah. Anyways, right, so we've got current bitmap. That's 0 to start off with, okay? We swap that round, so we're saying 1 minus current bitmap, which is 0. And that's our new bitmap. So that's current bitmap is now 1. We wait until the end of the frame, until the vertical blank, and then we switch to drawing on... Yeah. And then we erase our graphics and we redraw them, and we can take as long as we want to do that. It doesn't matter. Basically, if we take 10 frames to do this, it just slows down the game. It doesn't. We will never see that, because we are currently, once we hit use bitmap here, we're drawing to bitmap 1 when we're showing bitmap 0, and then we go around the loop, we start again. We show bitmap 1, and we swap to current bitmap 0, and then we're drawing to bitmap 0. Okay, it's kind of simple, really. It is. It's quite a simple concept, but let's give that a go, and hope it works now. Okay, there's our bitmap, our background, rock solid. And that will work as well with Blitz with the erase trick there, because it's because it's a simple thing. Yeah, and I can go one further, because I was doing exactly. Pay no attention to the man behind the curtain. Mm-hmm. Exactly. And like I say, you can take as long as you want. The graphics will get jerkier, like as your frame rate drops, but you can take as long as you want to draw that rear bitmap. It will never be seen. And then you swap it when you're finished drawing. And that's it. So you can do your graphics, and if you need to take a couple of frames for it, it might or might not make any difference to your game. If it's a smooth game, you want it to go quick enough, but if it's not, yeah, you don't. And it's fine. But yeah, I was doing yeah, true. It still annoys the hell out of me going to Windows and having to learn F keys and Alt F4 for quit and stuff. So why is it not like Amiga Q? Because it's Apple Q, it's Apple copy, it's Apple paste. But now it's Control this, Alt that, and fuck that. But anyways, yeah, rant over. But yeah, you'll see I have some old streams where I'm doing some coding, and I'm not sure if you're familiar with it, but I have a Solus board. Yeah, and Andrew there will be familiar with the Solus board as well. But some of the old streams, I'm doing some software development, and I'm doing the firmware for the board is on my PC, and that's in C, and I'm doing that in click that in the microchip development IDE, MP Lab, and so I'm doing that, and all my shortcuts for that, and then I switch over to an entirely different machine, different keyboard, different layout, different kind of speed, different everything, and then coding Blitz Basic to do the user end software, and to match the update I've just made to the firmware. And it's kind of it has its moments, has its moments, but he kind of just, everything just slows down, and you kind of like, right, this is what I'm doing, and you just have to step through it. But you managed to get it all back together, and nothing caught fire, which is good, because I think I would have heard about it if you did. Just checking my phone here. No missed calls. Yeah. Oh. Oh. Oh, yeah. Yes, yes, yes. Are you going to tell Jens that? Yeah, especially the new accelerator connectors aren't great, and you need to nudge them out a bit, and it sorts it out. Yeah. Stressful. Oh, Jens will be delighted. But yeah, it's sometimes it's the obvious stuff, you know, and you kind of like, well, you know, that's always worked. But yes, that will do it. So new HDMI switch, I suppose. But oh dear. Yeah. That's excuse me. That's unfortunate. Okay, I got that much beer left. I'm going to talk for that much longer. Yeah, absolutely. And I've got another 10-15 minutes in me to cover anything else, or if anyone's got questions, I will cover them. But yeah, the rest of the video will be there if you want to catch up tomorrow or whenever, the next 10 minutes, listening to my drunken rants. I'm going to see what the next tutorial is after this. But yeah, you can use Buffer Blitz or Cube Blitz for that. Tutorial 7. Let's go into Tutorial 8 and have a look before you go. Example 1. Yeah, happy Friday night indeed. Oh, now we're getting into Blitz mode. Okay. Speech on Blitz mode time. Okay, good night, and I'll introduce Blitz mode and then probably call it a night for myself as well, because I have a 4-year-old and he'll be up at you know, if the last week is gone, he could be up in 4 hours. Yeah, now we're getting into the fun stuff, aren't we? Now, Blitz mode, for anyone who's not familiar with the with the concept, and you won't be if you're yeah, you won't be if you haven't used Blitz before. But Blitz mode is basically shutting down the operating system, and you know, sort of, it's what most games do. You know, they suspend the operating system and give you full control of the chipset. So you've got a couple of different graphical modes that you can use that aren't anything to do with the Intuition screens, and you yes, exactly. And it gives you there are a couple of very powerful sets of commands which just let you you know do the skid marks, do the worms and that kind of stuff. You know, it's basically proper games mode. Obviously, without multitasking, it's not a great thing if you want to make a system friendly game. But it'll hit the hardware something serious. It'll be nice now when that happens. You know, and there's, I suppose there's an advantage to having kids a bit younger, I suppose. It's almost that difference. But yeah. See, the problem I have with James, and you know, wouldn't change him for the world and all that kind of stuff, is that he is kind of old enough to do that himself already. So I'm not sure if I told you, but there a while ago, kind of woke up and, you know, oh, James is out of bed and he's in the sitting room now. He'll have helped himself to all his food. He has put a chair on top of another chair to get to the counter, so he can stand on the counter and get the top cupboard for people who aren't Irish. and get the stuff he shouldn't be having. So, you know, he's helped himself to a load of chocolate sprinkles for breakfast. And, you know, and he's also gotten up nice and early, and he's logged 4 hours and 9 minutes on Mario Kart. Like, you know, fuck it. you know, he's capable. It doesn't it doesn't you know, when this happens, it doesn't bode well for the rest of the day, you know, because there's you know, screaming and tantrums, and you know, it's like, I hate you. Yeah. yeah, you know, I was like totally impressed. And you know the thing is, like, after he's put in, don't know how many of these sessions he put in, but after these sessions he can genuinely beat me on some of the tracks. Like, okay, you know what, here, you've made it, respect, but I cannot give him that as in, like, oh yeah, well done, you know. Can't do that, because just because, you know. So, oh no, that's terrible, and I'm like so impressed. How he didn't kill himself climbing on a chair, and, you know, yeah. When he was 2, he had his little wheelie car, you know, they would sit on, and had a handle on the back, and he would wheel that in so he could reach the things on the counter. And yeah, again, how he didn't kill himself with the, you know, on wheels, like, yeah, yeah, very impressive. He's gonna go places, that child. Hey, Super Dan, thanks very much. That's a legend. Wow. Wow, look at that. Look at that. Yeah, I suppose I should, shouldn't I? just say, yeah, there you go. You're basically a grown up now. Yeah, legend. That is that's very generous of you. And yeah, cool. Good man. I appreciate that. That is that's cool. That's cool. It's not the it's not the kind of thing I expect, and that is awesome. Thank you. Appreciate that. Okay, so yeah, so Blitz mode shuts down the operating system. Shuts down multitasking. It basically gives you entire control of the you've done more than enough, Dan. Give you full control of the chipset. It you know what, it is one of the highlights of the Blitz manual. There's a command that's for it basically checks if 2 rectangles overlap, and it's called rects hit. And it even has a line at the end of the description in the manual that says, care must be taken with the pronunciation of this command. It's genius. I'm like, yes. I like you. The manual has its moments. But yeah, so you've got full control of the chipset. There's nothing else that's going to be vying for the blitter or any of the hardware. So, you know, it's all yours, and you've basically got full control of the timing and so on. So yeah, Sprite's hit is funny. Sprite shit and wreck shit. So what Blitz does is, you've actually literally got a Blitz command. Okay, and you can see it there, and that is the one that yeah. That's it. That is what shuts down the operating system. And we don't really need it when you get to end, because that gets back to Amiga mode anyway, but it's called Blitz mode and Amiga mode. Amiga mode is your normal operating system running, but there is also the Amiga command, and that puts you back, that restores your screen instantly. You know, you're back in the room, like you're in like you're hypnotized, back in the room, workbench, everything's back to normal as it was. Everything carries on, all the disk activity, etc., resumes. Okay, but you can't use the screens and the you know, the intuition stuff like Windows and stuff like that we had before. So you've got two separate libraries that deal with the graphics hardware in Blitz mode. One of them is the old one, and that calls a part of the display a slice. That's a little bit easier to use, but it's old and it's basically obsoleted, and it was kind of replaced by what's called the display library. And the display library is a little bit trickier to use, but it's way more powerful, and it supports AGA. So the display library, like, so if you've got Blitz, kind of like, I think it might even be 2.0 or maybe just the original Blitz release, you won't have the display library. But in 2.1 and beyond, the display library basically supersedes the what's it called? Slices library. Oh dear. But yes, so in the display library, you've got what's called a cop list, and this is what defines your display. Kind of like the screen command, you do an init cop list and you set up your screen. But if we look, you've got two different ways of doing it. You've got cop list number and type, or you've got all the other parameters. So the first thing you need is your cop list ID, 0. Okay, yeah, again, we're starting at 0. Now, the Y position, this is the long format, the hard mode. The Y position is 44. Now, this is because we're dealing with the hardware. We're not dealing with intuition where you have, sorry, 2 seconds. Yeah, come on in. I thought that was a knock, but maybe it wasn't. Yeah, maybe I should be a bit quieter. There's not really an advantage to the slice library. There are some things that are a little bit easier on the slice library that, you don't need as many commands to do them. But by and large, it's kind of much of a muchness, really. There's nothing really that the slice library can do that the display library can't. Maybe they're doing the mouse pointer thing, actually. The slices library has it has kind of like a bit of a mouse handler built in, and so you can just attach a sprite to the mouse pointer and it just does the mouse pointer for you. But on this display library, you kind of have to do that yourself. Oh yeah, display library fully supports all the chipsets. It just has the additional flags and stuff that AGA needs. So if you set up a 5-bit plane screen, you can do that on OCS, or a 5-bit plane cop list. So like, I tend to use cop list for everything. It's just the way it goes. But because I like it. But the reason you need 44 here, well, see, there are a lot of commands that are applicable in both. You see, so the mouse position commands and mouse movement commands are applicable in both. But I think the slices library just has kind of a built-in handler that actually draws the sprite in the right place, whereas in the display library you have to just take the sprite position and draw the sprite yourself. Not a big deal, but yeah. But yes, the slices library does have a limit on bit planes. Now, so in a cop list, because you're not dealing with the OS, you don't have overscan and all that kind of stuff. You've got the Y position is like an absolute value from the very start of where the chipset starts drawing, and that's 44. 44 down is kind of normally the start. I'm just putting my hand there at the top of the camera. 44 is around about right for starting on a CRT. If you start at 0, part of your screen is going to be missing. So 44 is about right. And now what we're doing is we don't define the width, because the width is just the width of the screen in whatever screen mode or resolution. 30 something free system. Yeah. I'm not sure. 30 something free CS onwards. No. You might find it's 30 something for NTSC. I can't remember, because NTSC might use a different. 44 is a good value for PAL, but you can experiment and see what's suitable. But okay, so what we define is the height. The width will depend on whether we define a low res, high res, super high res, whatever. Bit planes. It could be. Well, see, it depends on, you know, where you want the screen to start. You know, so 44 might leave a bit of a margin there, you know, and it might give you a more centered screen on, you know, you experiment basically. And emulation probably isn't the best. You're probably really better off setting that on real hardware. But 200 is the height, you know, so it'll fit on an NTSC screen anyway. 5-bit planes, sprites always has to be set to 8. Because if you set it lower, you kind of leave the other sprites kind of can be filled with random garbage, and you end up with graphical glitches. It's harmless, but just set it to 8. That's just a given, okay? And colors does not necessarily have to tally with your bit planes, because that is the size of the palette objects that you use. And if you use sprites and stuff, sometimes they are colored beyond the bit planes. And so you need to basically have this as big enough for your maximum, for the biggest palette you're going to use. And then the last one is number customs. Now, this is for custom commands, like copper commands and stuff like that. So for now, we're just going to leave it 0. But that basically reserves extra memory. Like 0 bytes is what it's set to. But that reserves extra memory. And now we're creating a new palette object. Oh yeah, Zuberdan, go for it. Yeah. Yes. -2. So you're changing pens halfway down the screen. Yeah. So the -2 doesn't. Yeah, so basically when you set -2, there are 2 different types of custom commands that you can use. One of them needs negative numbers and the other type needs positive numbers. So it doesn't mean you're minus you're subtracting memory from the reserved amount. It just means it's 2 bytes for one type of command or 2 bytes for the other if it's a +2. That's all. Does a copless with hex 15 and 32 colors take a lot more memory? The cop list doesn't take memory at all as such. It's the bit planes that take the memory. So if you set it for 32 colors, that's the normal amount of memory that the palette would take anyway. So, you know, because 5-bit planes is 32. But let's say you set up a 3-bit plane cop list and you reserve 32 colors. Yeah, you've got an extra. So 3-bit planes is 8 colors. So you've got 24 colors that are beyond what you're normally going to use, and that might be so you're basically, the memory that you're not using there is 24 palette entries, which is 96 bytes, or no, 72 bytes. That's all. Yeah. So you've got 4-bit planes, I presume. Oh, so okay, so 4-bit maps, 1 to 4-bit planes, and split with excess off. Okay, yeah. So this is what we were talking about earlier. I said I'd get to it. So excess on and off is a kind of a. It basically decides what happens if you've got more bit planes than you have on your shape. Do you blit all the way through all those bit planes, or do you ignore the extra bit planes? Basically, that's it. But yeah, basically it's the bit planes that take, because all a cop list contains is pointers to the different bit planes. So your bit planes can be larger than the screen, but it's not like an intuition screen where it sets up the screen for you. It's literally a cop list is just a set of pointers. That's all it is. So you might have more pointers than you need, but pointers are only small. They're only a few bytes. So yeah, I wouldn't worry about that. Now, PAL RGB sets the color in a palette, not on the screen. So what we've done is we've set up a palette object here with 16 colors. Yeah, it doesn't really allocate the memory. It's the bit planes. It allocates the memory for the palette, but that's a small amount of memory. You know, that's yeah, not much to be concerned about. So what I've done is I've set up a palette that has 16 colors. They're pens 0 to 15. This is PAL RGB, so it's palette object 1, which is our ID here. Color register 0, and then 0, 0, 0. So that's setting the background to 0. And now we're setting pens. Now I don't know why that's 16. That should be that should be 32 color palette. So now we're going from 1 to 31, and we're just basically filling that in with random colors. Now we're only going from 0 to 15 because this is OCS ECS land. You can do AGA PAL, and then you've got the full range of 0 to 255 for the red, green, blue values. But because we're OCS ECS compatible, we're just going to do it from 0 to 15 each time. So basically what we've done here is we've set up a 32 color palette object. We set color 0 to black, and we've set 1 to 31 to random colors, completely random colors. And now we set up a bitmap. This is bitmap 2, same size as the screen, 320 by 200, and it's 5 bit planes deep. And now we draw 100 random lines on it. Oh, and this time I've actually set it so it doesn't draw any 0 color lines. So 100 random lines. And then that's our bitmap setup. So now create display is what actually puts the cop list into action. Okay? So when you enter Blitz mode, nothing happens. You've got a completely blank screen. Your screen is idle. So create display sets it up. It uses all the pointers in cop list to start pointing at bitmaps and bitplanes and sprites, and everything suddenly is activated. And then as you found, you want to do display palette and display bitmap are are both kind of do what they say in the tin. Display palette attaches palette 1 to display 0 or cop list 0. And well, when I say attaches, it actually copies the information in that palette object onto the cop list. Yeah. Oh yeah, it seems great at the time, and he's like, yeah, this is awesome. And I was like, no, remember, none of that. And then bitmap, this does kind of the same thing. So this gets cop list 0 to display bitmap 2. That's all it does, and then it just loops around until you press the button. So let's see, and that's it. There's our display running. Nothing happens until we click, and then it goes back to Amiga mode, and that's it. But that's a working display in Blitz mode. I just have a quick look at what's next. Example 2, smooth scroll sounds good. Oh, look at this. Look at this, we're moving, we're scrolling. So, this is the same program, it's just been modified a little bit. So we've got actual positions, and the bitmaps are 640 by 400 instead of 320 by 200. So our random lines are all spread out all over the place. Everything else is the same. And we've got a speed variable, which is 5. And now, after the V weight, we display the bitmap every time we loop around. Okay, and see, we've got a couple of extra parameters here, which are X position and Y position. So they set where on the bitmap you want to put the top left of your display. Okay, so the cop list will have, like, the top left of your screen effectively is going to be 0, 0 at the start, but you can have the 0, 0 of your screen point at 100, 100 of your bitmap, and then 100, 100 of the bitmap will be up at the corner of 0, 0 of your screen, if that makes sense. Okay, so now what we do is we do X position. Now, oh, there's some shortcuts done here. So joy X and joy Y are functions that return the state of the joystick in port, whatever you say, port 1. So that's our joystick port. So they return a 0. So joy X is about the horizontal and joy Y is the vertical. And so joy X returns 0 if it's in the middle, -1 if it's left, and +1 if it's right. Okay, so what I'm doing here is, this is a bit of a shortcut. So our X position is 0, and we're adding to that the joystick output times speed. So that basically means that we increment our X position by 5, +5 if it's going right, and -5 if it's going left. And then we do the same with the joy Y. Oh, of course, we check to make sure it doesn't go above 0 and 320. Now that should be 319. Should it be? Oh no. No, it shouldn't be, because it's... No, that's right. 320 is the 0 of the second half of the thing. Okay, so now we're actually going to do some scrolling. Oop, there's our bitmap. Oh, and that was fire. Sorry, that was the wrong button. Run again. Scrolling, scrolling, scrolling. Oh, diagonal scrolling. There we go. Okay, does this make sense to everyone? Did that make sense to people? Does that tickle anyone's fancy? Okay, I'm going to take that as a no and say that was very boring. Okay, so now we will see that we are getting slightly more fancy here. So what we've done is we've enabled scrolling. So that scrolling was fine. That's just moving our bitmaps around, or moving our bitmap pointers around. So that is scrolling. It's probably smoother than it looked on the stream, you know, because it'll run at 50 hertz. That's fine. But on the Amiga, you've got smooth scrolling, and especially in AGA, you can move fractions of a pixel. That's all right. So when we enable smooth scrolling here, we enable fractional pixel movement. And so if we go in, actually, I'll just show you in the documentation for in a cop list, we can see the flags that are involved. So see, these are the flags that are involved. Smooth scroll is a value of 10. Dual play field, you know, there's loads of other stuff like, and there you go, you've got the AGA things like high res sprites, super high res sprites, AGA palette, and fetch modes 1, 2, and 3 are AGA only as well. And super high res, well, it's not strictly AGA mode only, but it's serious, you know, to do anything significant with it. Okay. Yes, so there you go. For displays on non-AGA machines only, fetch mode 0 and low res sprites are allowed. But anyway, we'll deal with other stuff like that. But for now, we can see that the flags of $10 enable scrolling. So now everything else is basically the same. Speed, but you'll notice now we're using quick variables. Okay, and quick variables are fractional. So they're a bit slower to use, but what we can do is we can actually position the bitmap with fractions of a pixel. So X position or Y position. And yeah, so we're going to do the same thing basically, but we're going to be moving very, very slowly, because we're moving 1/8 of a pixel at a time instead of 5 pixels at a time. There's our bitmap. Now, okay, this isn't AGA, so you can see we are actually not scrolling at that speed. We're scrolling entire pixels at a time. Now, part of that. Oh yeah, you missed when we were discussing that earlier. Part of that is going to be because it's not in an AGA screen mode, and part of that is because WinUAE actually doesn't really emulate that properly. But what you can do is, normally you press help to get the information on the top bar. But if you press shift help, it jumps to the particular part of the manual. And I don't think that works in the original TED, but in Super TED it works, and in Amiga Blitz 3 it works. So the scrolling there is smooth scroll is enabled. But yes, so that should be working. I think is, like I said, it's probably because let me see if I can change the emulation settings here, because yeah, I'm not actually doing this on real hardware. Yes, it's fixed point. So if you've done assembly, it'll be 16.16 format. Yeah, so it's fixed point floats effectively. Ah, yeah, okay. Let me see. So let's see if I set WinUAE to that. Oh, that's ugly. Oh, you've broken my display, but let's just see if it works. No, it's still jumping away 1 pixel. Okay, there's something I'm missing here, because that is the flag for setting up for subpixel scrolling. Anyway, but I will ignore it for now, and that is an ugly, 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 ugly setup. Okay, and where's my display thing gone? But yeah, like subpixel scrolling, WinUAE doesn't really do it all that well. But I'm missing something there, because it should, I think, at least do half pixel scrolling. But anyways, you can give display bitmap fractional parts, like as in, yeah, quick variables, X position and Y position there. And if you look at something like Worms DC and you scroll around in Worms DC, you'll see that like sometimes the low resolution components of this display don't actually match up. And so you've got like sort of, let's say 2 pixels, and they're actually slightly overlapping each other by half a pixel. And you know, because of the parallax and stuff. And that's using this effect. But it's easier to see on real hardware where, you know, because the emulation if for WinUAE to do that, it basically has to render at 1280 pixels wide, and which is what AGA does. But doing it on, you know, it's a lot of wasted processing power on the host machine to do that on WinUAE. So it doesn't do it very well or at all. But anyways, yeah, that's something to look at another day. I think I'm going to say I'm going to call it there. Does anyone have any questions? 4-hour stream. Oof. So, any questions? You've got basically that long left, and then we'll go and raid someone. See who's around. Interestingly, there's a guy on playing. He's playing some of the old D&D roleplay games, like obviously the PC ones. So he's playing Planetscape Torment. Thanks very much. But yeah, like questions, and if anyone has any questions after watching this again, by all means. Oh well. Sorry about that. What were you trying to post there? I can switch off the mod thing there for that. Let's see. Where's my Nightbot? I've switched off the links. Not from you. Oh, okay. I don't know what that was about. I should enable that again then, because it's clearly doing its job. Okay, so no, it's fine. No problem. I'm only new to Nightbot, so I'm not entirely sure. But okay, yeah. Well, what I'll do is this is a good friend of mine from my hometown in Bray. Friend of mine, friend of my wife's, and he plays funky games. He has a funky beard. He usually has snack time late at night, and you place bets on whether it's going to be a biscuit or chocolate, and other quirky things like that. But I think we've missed snack time. But yeah, so let's just see and make sure he's still going. What's he doing? Oh yeah, he's running. So and some of the games he plays are pretty awesome. But yeah, so listen, thank you very much. Any questions? Join the Discord and yeah, ask away. You know, if you're watching this not live, or even if you're watching it live, you know, think of a question, ask me, and I'll get to it at some point tomorrow, I'd say. But yeah, thanks very much for the feedback. Thanks very much for the gift subs. Thanks for the subscribes. Thanks for the raids. Yous are all awesome. Brilliant stuff. Yeah, thanks a million, guys. And where's my thingy gone? Oh yeah. Sorry. Good night. Where's my raid button? I can't find where my raid button's gone because I changed some things around now and I don't know where it is. No, not that one. Oh, bear with me. There we go. Here we are. Let's raid Kiffer, Chris. And let's click. Good night, guys.
Is she on some kind of AI mode? Because I thought I told her to stand back.